Good morning, everyone. If you can hear me, type in good morning. Edric and Kelly, my early birds, good morning. Good morning, James. Cole, good morning. Bardia. Spencer, good morning. Samuel. Michael, good morning. Christopher, Ignore, Edison, Jespri, good morning. Greetings to you as well. Hannah, always a joy to have you back in the class. Raman, hello as well, my friend. I'm the boss. What does that make you? Who the hell knows, right? Let's have some fun today. We have a big class today, so I hope you brought your A game. Today's crucial. I know from experience, this course has a lot of has a tempo, and when you've taught a course several times, when you reach kind of like if I was a guide on a canoe and sort of explaining to you a river, and all the river bends, and the parts where they have the rapids, and watch out for this rock over here, and be careful for that, and duck because there's a branch, and that kind of stuff. You can imagine I know this really well, and we're at a juncture now. When I say you got to all hands on deck, like everyone grab their canoe paddle and start paddling, like it's really serious. So today is crucial. There's a lot of things we're going to accomplish today, and they're going to be pivotal, and we are going to have to just keep moving forward and forward and forward. So we've got a full plate. Here's what we're going to be doing. I'll have a look at the main document. I know folks are probably thinking about the recent test, the truth table test. That's about halfway graded, and so I promise you, always within 1 to 2 weeks, I'm totally going to fall within that range. So sometime in the next week, the results will be made available. I'm writing feedback, not a ton because there's no point. We're not doing truth tables anymore, but on occasion I'll flag where if you did something wrong, where you went wrong. But like just you can figure this out for yourself by going again on a second run. It's painful to kind of grade this one in particular, but that's what the nature of the work is. So that'll be done sometime in the next week. We'll have a look at our main document. And just we're entering chapter 3 here, so we got to be real clear on what's the blueprint, where we're going. Today we're learning something called derivations. I'll talk about how we can reassemble what we know. For a week, we're going to lower the bar a little bit and put some restrictions on the sorts of connectives we have access to and the sorts of inferential moves we'll be doing. So I'm going to be pressing a little bit on the pedal, and then next week we'll be pressing full throttle on the pedal. And the reason for that is to give you a chance to learn. In my experience, if I taught you the whole kit in one go and I had you practice, it would be too much. So what we're going to do is we're going to scale it back for 1 week, and then next week we'll go full throttle. So that's going to mean that we're going to have 4 watertight ways of reassembling our pipes. We'll learn how to do derivations. There's a lot of important things that are going to happen later in our class today. So keep your mental energy up. Because it's not like you want that thing to start waning, and then it's going to be crucial information at the end. And then we'll practice. So I'll send you off on your way for your homework, and we'll try to put everything together in a way that at least we do, like to say, the first exercise of the homework together, and that way you can get a sense of what you're supposed to do, and then off you go. And there's 21 exercises this week, and that's a magic number that we'll keep for a long while. 21 is 7 times 3. If you really are concerned with doing well, my recommendation to you is you do 3 questions a day. So that's 3 questions a day. It's 21 questions per week. I've paced it that way. If you keep that regimen, you'll be on the right track. If you cram, you will be screwed. And I mean like majorly screwed. Unfortunately, every time I get to this part of the river, there's someone who's not paying attention, and whoa, off they go, right? They're in the rapids, and we lost them. And so just be mindful. My goal is really to sort of get you to your destination, which is to do well in this course. And I think that by now, week 9, you can trust me, right? You know that I keep my end of the bargain. I'm not jerking you around. Every minute is well spent. Everything I tell you is useful. That said, your end of the bargain is you got to do what I tell you to do. And if you do that, everything tends to work out pretty well. Right? So that's what's on the menu for today. Does that sound like a plan? Is everyone alert? If you're good to go, tell me GTG. Good to go? I'm stretching. I'm good to go. Man, I'm always good to go. Certainly at this time. Let's do this. I'm going to have a sip of my coffee. It's tough for me too, right? I got to teach this. By the way, I could give you recordings of this class. I taught this several times. But I want to do it in a way that you're there. There's another person that's kind of like putting in the pain with you, and I'm responsive to your concerns. So it's more work, but I feel like it's worthwhile. On that note, let's have a look at our main document. We've done a lot now. So we're entering, remember, I kept this course really silly in terms of its structure. So 3/3, right? 1/3 that's going to be on one skill, symbolization. That's done. That's in the can. Another that's on truth tables. That's done. You're going to get your results sometime next week. And now we're at derivations. Notice that also in terms of weight, this is the one that weighs the most. True, the test is 25%, but you will have 2 of your 3 quizzes that are worth 10% are going to occur as part of this month, so March 20th and March 27th. And the reason for that is, again, in my experience, and this is not just pure theory, it's practice. I've exposed this to the classroom. I know exactly when students need a little more incentives and practice. You need a lot of preparation, right, to get ready for this, a little more than you would, let's say, for the truth tables. So if you thought truth tables were hard, well, it's going to be harder. And if you thought they were easy, well, that's terrific. Then means we're going to be harder either way, right? So you're going to have 2 quizzes. Let's look at our week-by-week breakdown to know what that means on a timeline here. Week-by-week breakdown is a really valuable tool for us. This document as a whole is a really valuable tool. I certainly couldn't wrap my mind around what we're doing without checking in on it periodically. So here you go. 3rd month skill is derivations. This is today, March 6th. We're doing 4 inference rules using only the conditional and negation. As I told you, we're going to scale back some of our resources. Look at your homework here. Memorize the first batch of inference rules. Do the first derivation homework. I could have added as well, there's lots of files I'm going to be putting at the end of the class on Moodle, and you need to read all those. There are files I will be discussing in class today, but there's a lot in them. And when I mean a lot, it's not that there's a lot of text, but it's precise. And these are going to be the guidelines and rules that are going to tell you how to do these derivations for the whole month. If you don't know what a derivation is, don't worry, by the way. It's not math. It sounds vaguely mathematic, but it isn't, and you'll understand by the end of today. Next week, what we're doing is a mock quiz. And this is also something that I've added because I've seen people always screw up this quiz. And I thought, geez, Louise, why don't you learn that you need to crack that whip over here? So if you do everything right, the mock quiz should get your heart rate a little bit and get your heart rate up, and it should be a way for you to know exactly what the quiz was going to look like. So the homework resembles the quiz, and the mock quiz resembles the quiz, and the quiz resembles the test. The idea is I want to get you to practice and to not be stressed out about the format, but really sort of be exposed to the flame. And so we'll do a mock quiz next week. Notice that I didn't put this in bold because it's worth 0%. If you do all your homework correctly, which is 3 times a day for the whole week, you'll be just fine for that. And then there'll be another 21 homeworks for you to do, and so on, rinse and repeat. It's always 21, right? And you should be doing okay. And then it starts to matter. So I've given you a lot of incentives here. It's going to show up on your final grade. Excuse me, quizzes here, quizzes there. It's more grading for me. I'm going to trim one of your worst performing quiz. So it ends up being wasted work for me to grade all that stuff. Nevertheless, in my experience, it's important to have students have that incentive. If we don't have something that shows up on your transcript for too long, students get complacent, and you have no real measure of whether or not you're doing this well. It's not just about thinking harder. It's about really exposing yourself to the flame. So that's what we're going to be doing. So look at the pace here. It's very serious, right? We're entering that last month. And if you saw the Karate Kid video that I put, this is the big match, right? You're against a strong opponent. And what we're going to be doing for the next 2 weeks is learning the skill itself, and then we apply it. So here's going to be new content. And everything else after that, maybe with the exception of, I'll throw in a couple of things on theorems around week 11 or week 10. Sometimes I put it in week 10. That depends on how things are going. But everything else after that is going to be application, application, application. So 2 weeks of learning the skill, and then the remaining is just apply. And notice here I've packed on the 13th week, our last week before the final, pre-test prep and practice. Again, a whole workshop. We get together and we just practice and practice and practice. And that practice only makes sense if you do the homework each time. Otherwise, it's a complete waste of time. And what do we have beyond that? Well, after week 13, there's week 14, which is Easter Monday, so that's no class. That doesn't mean you just sort of sit on your bum and you watch Netflix. You want to practice. And then we've got our final exam, and that's going to be on April 17th. And contrary to our exam that we just did, our final test, our truth table test, it's going to be starting at 8:30 a.m. because that's the official schedule. And remember our deal, that's you, that's me, and that's us. And so you got to hold your end of the bargain for the thing to work. That's our week by week breakdown in our main document. Are there any questions about any of this? If you have a question, please ask your question. If everything's clear, go ahead, type in clear. I need to know. Also a good opportunity for me to eat my egg whites. Okay. I hope you're having breakfast too. Did you have some food? Type in yes if you have food. I want to see how many people have food with them. And you know it makes a difference, right? Yeah, you need something, right? Tea could be good. Some sort of pharmaceutical support, right? Because when we near the end, man, after we try to finish before 12:15, I don't know if we'll be able to do that today. I'm certainly going to gun for it, but man, it's like the brain power comes down. So do make sure you have what you need to succeed. All right, let's look at derivations. Let's kind of figure out the main idea and ramp ourselves gradually over to what our skill is going to be. Um, Remember, we saw this in the very beginning when we were looking at symbolization. The fundamental unit that we're handling throughout this entire course is an atomic proposition. That's the basic building block that we've been manipulating. An atomic proposition, as you know, is the smallest grammatically complete unit that can be true or false. So if I say this block is blue, that's a proposition. Turns out it's a false proposition, but truth or falsity are not things that we're concerned with per se. We just want to track the possibilities, not necessarily explore which of those worlds we live in. Right now, it kind of wears it on its sleeve, the saying of falsehood, right? But nevertheless, this is a proposition, an atomic one. That's been the building block. That's not going to change. We're still going to have atomic propositions as our basic building blocks. Here's a compound proposition, right? And notice that they can have distinct truth values for the whole and the part. So remember, we saw when we were doing truth tables, right? You can have a situation where, let me grab myself a marker here, right? It could be true that she smiles, and it could be false that she has friends, right? And there's all sorts of possibilities as well. It could also be the case that it's true that she smiles, and it's true that she has friends, or it could be the case that it's false that she smiles, and it's false that she has friends. And then we had the different ways of connecting all of these different possibilities. Our connectives were ways in which we relate these, so and, or, if, then, and all that stuff. That's still going to remain. Now, if you imagine these Lego blocks, remember our goal is to reassemble those Lego blocks in a way that, we want to maximize coherence. And as I just said a moment ago, we're not concerned with correspondence. There are these two axes that we could be concerned with when we're studying knowledge. In logic, we're only concerned with coherence. So you can think of logic as the science that studies relations between units of knowledge. And the one that matters the most for us is the relation of validity, the one of deductive entailment, where the premises really mandate their conclusion in a way that's 100% secure, right? We're once again, going to sort of keep in that same orientation. Nothing changes. What we're going to be doing is we're going to be reassembling what we know into something further. So what we know, the technical name for that are the premises. So take all those Lego blocks to be atomic propositions, right? And we reassemble them in various ways. And what we want to do is we want to figure out what we can infer with 100% certainty from what we know, and that would be the conclusion. So imagine, for instance, you're just looking at Lego blocks. You got the Lego blocks on the left. That's the premises. And you got the Lego blocks on the right. Could you end up with what's on the right from what's on the left? Could you reassemble the Lego blocks so as to obtain what's over here? Is that possible? Yes or no? Yeah, totally. Samuel says yes, right? You could totally do that. Look, there's a blue block over here, right? And there's a purple block over here. And you could totally reassemble these things to obtain what you have on the right. So that's what we're going to be doing. We're going to be figuring out ways of reassembling them. Just to kind of massage your intuitions here, could we go from what's on the left to what's on the right with 100% certainty? Could we just go ahead and do that? Is that a way of, like, imagine I give this to my kids as a task. Can you go from what's on the left to what's on the right? Yes or no? Take those Lego blocks. Could you do that? Yeah, totally, right? Totally. Again, that's a no-brainer, right? We're playing with Lego. What about this? Could we make this structure given the basic materials we have on the left? Totally. If I gave that as like, imagine I have a whole box of Lego for my kids, and I tell them, could you build this structure? They could totally build it. What about this? Could you go from what's on the left to what's on the right? No, that's the correct answer. Why not? Exactly, right? There's a block too many here that wasn't available to you as your starting premises. Your conclusion now is including contents that weren't present in the premises. And what that means is it's no longer 100% certain, right? Remember the goal. It's not just to reassemble stuff for its own sake. You can do that. It's to reassemble things in a manner such that you can proceed from the premises to the conclusion with 100% certainty. And we don't know this for a fact. Now, for all I know, whatever that Lego block represents, because it's a proposition, it could be true, it could be false, but we certainly can't infer that truth or falsity from the premises that we were given. Not possible. So remember the goal: 100% certainty, just like we did for the truth tables. That's what we want to do. We want to find ways of reassembling our knowledge in ways that are 100% certain, right? Now, for the following week, we're going to arbitrarily make a restriction on the resources symbolically that we have at our disposal. You know from the beginning of the semester that we're working with 5 connectives: negation, conjunction, disjunction, conditional, and equivalence. For the next 7 days, and this is only going to last for the next 7 days, we're only going to be using negation and conditional. And the reason for that is you'll have a lot to learn, and it's going to make it feasible for us to learn it if we do that. Otherwise, it'd just be too much, and your brain would just kind of, just come out of your nostril. And so we're going to be making that constraint momentarily just for 1 week. We will, reopen the valve next week. We'll reintroduce all of these connectives and all that they allow. But right now, for the following week, we're only going to be doing this. All right. Likewise, we're going to be learning what are called inference rules. There'll be 10 of them. You're going to be memorizing this. You'll understand what this means, and this will become second nature to you. But for the following week, even though we have 10 that we're going to learn and deploy, we're going to be focusing only on 4. So we're going to cut it down, and we're going to limit ourselves to just those 4. So we get those handled properly. And again, we sort of lower the bar a little bit. We get to know the skill really well. And then the following week, we're going to reopen the valve once again, reintroduce these 6 additional ones, and we'll have the full kit. And this will be the basic manipulations that you'll have at your disposal. We're going to reassemble what we know in 10 different ways. And that's what the basic sort of vocabulary of transformations that you'll have at your disposal. But for the following week, we're going to be doing only that. My friends, let me check with you. Is that clear so far? For 1 week, we're going to lower the bar and just cut back on stuff. If that's clear, type in clear. If you got a question, ask your question. Just for 1 week. So don't be surprised next week, right? We're going to reintroduce these things. All right. So all of this is a preamble to study different ways of reassembling what we know. And remember, we used the analogy when we were doing truth tables with plumbing. And when we talked about truth tables, we said it's a way to verify whether or not we have before us a configuration of perfect plumbing. And we said, well, what's perfect plumbing? It would be something that carries the truth of the premises over to the conclusion without loss. If the premises are all true, then the conclusion has to be true. Well, the main idea behind derivations, if you want to continue with that analogy, is the following. If you take water plumbing and you connect it to other watertight plumbing, so imagine you have a piece of plumbing and you know for a fact that it's watertight, and you have another piece of plumbing and you know for a fact that it's watertight, what do you get? So you take 2 pieces of plumbing, you both can certify that they're watertight, and you connect them, moreover, in a watertight connection. What do you end up with? Watertight plumbing connected to watertight plumbing gives, and I might say connected in a watertight way to watertight plumbing, yields what? Watertight plumbing. You guessed it, my friends. Exactly. So this is the main idea. If you have something that you know already is watertight, and you have another thing that you know already is watertight. So let's imagine, for instance, this entire sub-segment here, that's all watertight. And you know that this entire segment over here is watertight. And you know, moreover, that the way you're connecting them is also watertight. Then you're going to obtain this entire new hole that's going to be watertight. That's the idea. What we want to do is we want to go as plumbers, and we want to walk into the world with a few little tools inside our toolkit. What we want are sorts of pipes that we might want to connect together. Now, what sorts of pipes might we want to connect together? We want pipes that are going to be valid, that is watertight, so we can trust them, and simple, so that we can recognize them. All right? So what we're looking for are argumentative patterns that are valid and that are simple. Like you can imagine, I'm not a plumber, but if you have this, I'm pretty certain you can kind of reassemble these to meet whatever new home you're going to encounter. So let's say someone phones you up, you're a professional plumber, so you hop into your van and you go to the location. You've never been to this person's home before, you don't know what you're going to encounter, but you know that whatever happens, if you have this basic vocabulary of connections here, these basic watertight connections, right, you can kind of pretty much cope with any situation you confront. Everything is going to be just fine, right? You just keep reassembling these, and in the manner that we had a moment ago, right, you can accomplish pretty much whatever you want if you reassemble them. That's what we want to do. We want to identify small argumentative patterns that are valid so that we can know that we can trust them, and simple enough that we can recognize them. Nothing too complicated. Now, let me just kind of show you concretely what that means. Here's some arguments in ordinary English. I'll read them out loud. If a person has a religious experience, then that person believes in God. This person had a religious experience, therefore, this person believes in God. And of course, we know from the first month how to symbolize this, right? What you would end up with is if R, then G, R, therefore G. Let's look at the next argument. If you do not take your medication, then your skin rashes. You did not take your medication, so you got skin rashes. And again, your month one skills would allow you to symbolize this as if not M, then S, not M, therefore S. Here's another argument. Michael acts professionally and wears a tie. If Michael acts professionally and wears a tie, then he looks like a boss. We can therefore conclude that he looks like a boss. And once again, you know how to symbolize this. You've learned this in the first month. Now, notice these arguments. There's an argument here about religious experience, another about taking medication and skin rashes, another about acting professionally and wearing a tie, right? Once we've symbolized them, we can get rid of the language. So fair enough, we're left now just with these symbols. I want to ask you a question. Forget the language now, the normal English. Just look at what's on the screen right now. What's common to all of these arguments? Take your time, have a look. And no one's being graded, right? So whatever you say in the chat can only be helpful. No matter if you F up, that's the point. Just put it out there. I'm not grading you. It's no big deal. Hannah notices that the conclusion in all cases is atomic. That's exactly right. They all have an atomic conclusion. That's true. That's true. What else are we observing? Samuel observes that there's two premises in a conclusion. One premise, one premise. One premise, one premise. That's exactly right. Good observation, Samuel. Keep going. Keep looking, everyone. Correct observations. Just scrutinize this. Tell me what they all have in common. Max notices that conditionals are involved. Yeah, they all have a conditional. So at some point, there's conditional over here, there's a conditional over here, and there's a conditional over here. So at some point, they involve a conditional. That's exactly right. Keep looking. Everything you've said is correct. Keep looking. Yeah, Edric, that's right. That was the first observation about the atomic proposition. Keep looking, folks. And everyone have a look, right? Everyone's looking at the same screen. Be courageous. I don't want to keep hearing from the same people. Take a risk. If you spot something, let me know. They all involve conditionals. They all have two premises. Samuel writes, the antecedent of the conditional in one of the premises is involved in the other premise. Well, that's interesting. So Samuel, let's have a look at what Samuel says. Samuel says the antecedent of the conditional in one premise is involved in the other premise. So let's look at this. This is a conditional. And notice how there's the antecedent of that conditional. This is a conditional. And notice how the second premise here is the antecedent of the conditional. This is also a conditional. And notice how, here you go, you have the antecedent of the conditional. What else can I, that's a great observation, Samuel. First of all, let me pause. Can everyone see that? Type in yes if you can see that. I think once you draw it, obviously it's more clear, right? So what else? What else is happening? Let's make a further observation. We're on the right track. Let's make a further observation. The consequent, ignore, good observation. The consequent of the conditional is the conclusion. The consequent of the conditional is the conclusion. That's a great observation. Let's verify whether ignore is right. The consequent of the conditional, right, is the conclusion. Terrific. Can everyone see that? Type in yes if you can see that. That's also true. Yeah. Good observations, my friend. Very good observations. So notice, even though these arguments, and you can clearly see in English how they bear no relation to one another, if you symbolize them, you start looking at their deep logical structure, and you realize, wait a second, essentially, these are basically the same form of argument. If you squint a bit, you start seeing a pattern. Here's the pattern, right? Essentially, the pattern is this. And notice I'm trying to make the pattern come alive here. So I'm going to just replace it with whatever, right? You have a situation where you say, if this, then that, right? This, therefore that. This is essentially what we have. Look carefully. Look carefully, right? If this, then that. Let me just kind of erase all this, right? If R, then G. R, the antecedent is being affirmed. Therefore, the consequent is concluded. Here we have a situation where if not M, then S. Well, fair enough. But I just said if not M. I didn't say that not M. I said if not M. Well, all of a sudden now I'm putting my foot down and I'm saying not M. And therefore, the conclusion is the consequent, S. Once again, same thing. Someone's putting their foot down right away and telling you that P and T. Fair enough. And then they say, if P and T, then B. But hey, we've already put our foot down and said P and T. We've actually affirmed the antecedent, and then we conclude the consequent. The pattern in all instances is this. You have a conditional, you have the affirmation of that conditional's antecedent, and you thereby infer that conditional's consequent. Let me say it again slowly. And notice this is technical jargon that we're familiar with. You have a conditional. You have a premise that affirms the antecedent of that conditional. And because you've now affirmed the antecedent of that conditional, you can now conclude the consequent. Can everyone see that pattern? Type in yes if you can see that pattern, if that's clear. Question if you've got a question. A conditional, then you go from being if something, you actually affirm it, right? Because it was just if, right? So it was an if cloverleaf. If. I didn't actually commit myself to cloverleaf. It's in the subjunctive mood, right? If. All of a sudden we're saying, but in fact, it is the case that, and now all of a sudden we're entitled to say heart. And notice here how it doesn't really matter the order in which this would be presented, right? And what you have is a form of argument that's really basic. And remember, we want to look for tight little plumbings, little pieces of plumbing that would be useful for ourselves. This is one that we're going to keep in the mix. We're going to put that in our box as plumbers. We're going to call this a modus ponens or MP. Believe it or not, medieval logicians spent a lot of time cataloging all of the different kinds of arguments and giving them names. And the Latin name for this particular argument that you're looking at right now is modus ponendo ponens. Short form, we call it modus ponens. We're going to call it MP or modus ponens, right? MP for short. That's going to be one of the little things we're going to put in our box. And notice, importantly, that the order in which the premises show up is unimportant. It's the same, what we're looking at right now is the modus ponens. You have a conditional, you have the antecedents conditional that's affirmed as one of the premises, and that allows you to conclude the consequent of that conditional. So for instance, if I say, you smoke, if you smoke, you'll get cancer. Well, given that I've said that you smoke, and given that I've said if you smoke, you'll have cancer, if both of those premises are true, then I can conclude that what? Given what I've just said? You've got cancer. That's right, you'll have cancer. And notice how this is a perfectly secure piece of plumbing, right? If the first premise is true, that in fact you smoke, And if the second premise is true, that if you smoke, you'll have cancer, if both of those things are true, then you have to conclude that you'll have cancer. That would also have to be true, right? So this is a piece of perfect plumbing. And if you don't believe me, then you can check with the truth table, right? If P, then Q, P, therefore Q, right? Modus ponens is a great pipe to use for us because it's valid. And moreover, the second feature we're looking for is that it has to be simple enough to recognize. And look, it's really simple to recognize. It has the following form. If you say I have one premise that's if antecedent, then consequent. One of the premises that affirms the antecedent, and the conclusion concludes the consequent. So it's simple enough to recognize. Now, when I mean simple enough to recognize, I don't mean that we'll always encounter if P, then Q, P, therefore Q. And notice there's nothing magical about P that could make it an antecedent, right? So you understand, everyone, that this could easily be if Q, then P, right? We can, P, and we could easily replace these, right? And in order to be a modus ponens, what would I need here as my second premise? If this really was a modus ponens, if I say if Q, then P, I would need, that's right, I would have to put Q over here, right? So this would have to be Q. And then what could I conclude as a conclusion? If I have if Q, then P, Q, therefore P. You got it, P. Right? And notice it's the same pattern, right? A conditional, the affirmation of the conditional is antecedent, and allows you to infer the consequent. Now, this is going to be really neat for us. It allows us to sort of spot patterns where we previously couldn't see any, right? A pattern like modus ponens or MT can be found at any scale, any scale. So, for example, look at the argument here. I mean, this is kind of scary if you don't know anything and I were to ask you what's the conclusion. I said, what the hell do I know? I haven't made a truth table for it yet, or I haven't figured it out, right? Like, what the hell is the conclusion? But let me have some fun now. Let me color code this for you so you can see it a little clearer. What's the conclusion? Yeah. Q equivalents P, right? Cole's found a way of finding a way of typing the equivalent sign. Jaspreet, very creative use of the little symbols, right? But look at the conclusion here. We can just at a glance know the conclusion. Because remember we said a moment ago, this is a piece of perfect plumbing. So it's secure. You know that modus ponens is a piece of perfect plumbing. Well, if it's a piece of perfect plumbing, it's a piece of perfect plumbing at any scale. It doesn't matter what you plug into P. It doesn't matter what you plug into Q. And what you could be plugging into P could be something very big. It could be a whole compound proposition. And what you're plugging into Q could also be a compound proposition. And you know that that's going to be a valid sequence because you can test it. So what you can do is you can look at a situation like this and you can say, wait a second, I recognize this. I'm looking at a modus ponens. Really? Where? Well, look, here's my antecedent. It's only being if, right? It's a conditional, so it's not actually being affirmed. But my second premise is actually affirming the antecedent. And of course, if I affirm the antecedent of a conditional, I'm able to infer its consequent. And notice how, at a glance, without doing anything, we're able to infer the conclusion. Isn't that a neat trick, my friends? Without doing anything, we can figure out the conclusion. Now, tell me if that's neat, because I think that's pretty cool. What do you folks think? You want to impress your friends, you tell them, you know what? Just by looking, I can figure out the conclusion of this argument. That's going to impress your mom. If your parents are wondering if they helped you out with laundry or tuition or whatever, and you want to show them that you're becoming smart, show them this, right? It's like, I can do this, Dad. Really? Check it out. I can just look at this and figure out the correct answer. It's super satisfying, I would agree, right? And you're going to find the trade-off. Remember, this month is going to be really hard. But the trade-off, Jaspreet and everybody else, is you're going to find this thrilling. You're going to have a buzz. It's really satisfying for your mind to be at full capacity and to exercise itself. So it's going to be fun. So this is modus ponens. That's one of the pipes that we want in our kit. And essentially, if you were to put it in Lego blocks, it would look like this, right? We want to proceed from what we know. to what we can infer with 100% certainty. Well, what do we know? Well, we know that if she smiles, then she has friends. And moreover, we know that she smiles. And notice that's a different move now. I'm asserting the actual she smiles. Here, I'm just asserting if she smiles and she has friends. I'm asserting the conditional. I'm not asserting that she smiles. The second premise does different work. It's actually asserting that she smiles, and therefore we can infer that she has friends. And that's really, really powerful way of drawing a conclusion, and irrespective of what fills those blocks. So generically, you can remove if she smiles and whatever, all that stuff. Plug in whatever the hell you want over here. Plug in whatever the hell you want. And whatever the hell you want, I mean stuff that could be both atomic or compound. It doesn't matter what you plug in here. Like if I decide to say, for instance, and you know, help yourself to the most scary, long, I don't know, a compound proposition, something that would give you nightmares that, before taking this course, you would have been terrified in seeing, right? Let's say, I don't know, what else, right? So make it really scary, add some whatever. If you have that over here, well, if it repeats itself over here, and whatever scary thing you want to plug in this block, well, you can infer the consequent. Right? So long as you affirm the antecedent of a conditional, you can infer its consequent. And it doesn't matter what's in these Lego blocks. It can be atomic or compound. And there's no limit on scale. So I can have a complete book. If this complete book is correct, now a book is a big thing, like a 500-page book, then this other 700-page book is also correct, book red, right? Well, if purple book is right, then red book is right. Purple book is right, therefore the red book is right. And it doesn't matter that each book is a complicated thing filled with arguments, that if you open them, you'd see a ton of things. You can, without opening the book, if this book is right, then this other book is right. Right? My friends, is that clear for modus ponens, this pattern that we're looking at right now? If that's clear, type in clear. If you've got a question, ask your question. I'm taking you a bit slow at the beginning because I want you to really understand what the hell we're doing. Yeah, and that definitely will not have a shortage of examples. But not so much examples where we're giving an interpretation in ordinary English, but certainly symbolic examples, those will abound. So you're going to be doing modus ponens. It's like jab, jab, hook, man. If you're going to be doing sparring, you're going to be doing that quite a bit. Jab, jab, hook, jab, jab, hook. You're going to do that a lot. All right, let's have a look at another one. So that's one for the little box called modus ponens, right? And we can generically sort of summarize it by saying, if P, then Q, P, therefore Q. And I want everyone to be 100% clear here. There's nothing magical about the letters P and Q, right? It's just its generic form. We understand that P and Q here could be substituted by something of any scale. And there's nothing magical about P that makes it more disposed to be an antecedent. It could be whatever, but it's just we need a way of noting it down. And this is going to be called modus ponens or MP. Now, I said we want 4 in our toolbox. Let's acquire another one. Here's another one. From what we know, those are the premises. Premise number 1, premise number 2. We can infer this with 100% certainty. So imagine I say, if this yellow thing is true, right? If this yellow, then this green. It's not the green, therefore it's not the yellow. So again, if you wanted a sort of English interpretation of that, we can have some fun. I'll just give you one interpretation, right? Let's say, I don't know, if there was fire, then you would see smoke, right? And you can infer, well, if that's true and you don't see smoke, then you can infer that there is no fire, right? Or likewise, you could say, for instance, if this theory were true, we'd expect to observe the following things. This is very common. If you do philosophy of science with me, you would learn the structure. If this theory is true, then we'd expect to observe the following things. Well, I'm sorry to report that we don't observe the following things. Therefore, the theory doesn't hold. That's how we falsify a theory. Theories have observational consequences. If we fail to observe the observational consequences, we thereby falsify the theory, right? And this is a move. It's fairly straightforward when you see it like this. It has multiple interpretations. You could plug in whatever the hell you want in the yellow and in the green. It matters that we're denying here the green part, not the yellow part. But if we deny the green part, which is the consequent, we can infer as a conclusion the denial of the antecedent. And that move's also going to have a Latin name. It's going to be called modus tollens, or MT. And notice MP and MT kind of sounds the same, so I'm always going to really bite down on that. I'm going to say MT, and it looks like this. If P, then Q, not Q, so not the consequent, therefore not the antecedent. My friends, is that clear, everyone? If that's clear, type in clear. If you've got a question, ask your question. Another move, right? Another move. And notice, by the way, just to be clear, if you're kind of not paying attention, look how these two kind of look alike, right? If you're not paying attention, they kind of look alike, but there's crucial differences. A modus ponens consists in the affirmation of the antecedent, and a modus tollens consists in the negation of the consequent. The affirmation of the antecedent allows you to infer the consequent, and the negation of the consequent allows you to infer the negation of the antecedent, right? You can't just make up whatever you want. Like, for instance, if I say this, if P then Q, or fair enough, and then I have not Q, and I infer from this P, is this a modus tollens? Yes or no? Not only is it not a modus tollens, and why is it not a modus tollens, by the way? What's going on here? Why is it not a modus tollens? Let's unpack that. No, you're correct. It's not, but why? Yeah, you need to negate the antecedent, right? That has to be the conclusion, has to be the negation of the antecedent. That's right, Samuel. This would be invalid. So if you were to actually test this one, it's invalid. So remember, we want just not any kind of patterns. We want valid patterns in our box, right? It's like, what sort of plumber would I be if I come to your house and all of my, my plumbing pipes are full of holes, right? It's like, no, we want watertight plumbing. So it matters crucially. So be careful, nitpick here. Slight modification. You can't just, be foggy in your mind. You got to really be focused. All right, here's another pattern. And this one's a pretty no-brainer, right? From what we know, we can infer the following with 100% certainty. Like, if the blue book is true, whatever the blue book said, red book, right? Suppose you say book, right? And you plug in here whatever you want. I like the example of a book because that's one complicated atomic, compound proposition with conclusions, in fact, inside it, right? Well, whatever is the thesis of this red book, right? If it's true, if what the book says is true, then clearly it's also true that it's not the case that not it. Clearly. Because what is this saying? It's complicated, but it's painful to hear in English, but it's saying it's not the case that, which essentially reverts back to asserting it. This looks like a little person right now. I'm actually seeing my face detection module has just been activated, and I just cannot help but wrap this one up. Right? Although, like, isn't that cute? Right? But there you go. Right? And that's a no-brainer. Like, you can graft a double negation, and it reverts back to, again, I'm seeing a face. This one's kind of happy now. I wrote a paper recently, and it's got the really coolest visuals. I'm going to be publishing an article, and it's got like the coolest visuals of life because I show all of these. Actually, I got to show you. Let me find this. You kids are going to love this. Let me go into my files. Because now you're going to think I'm crazy. So I actually have to show you. Hold on. I'm using papers. You're going to love this. All right. I'm going to show you. Because now you're like, what's the prof talking about? You're going to love this. No, that's not what I want. I just want this one particular thing. No. Hold on. I want to stop sharing. I need to open the file itself. Thank you. And I want to open this particular thing. There you go. You're going to love this. It's going to be worth your while. Let's go add let's go add my image. Come on. I just want to zoom in. What is this crap? How do you like those, my friends? This is an article I'm publishing recently, soon. Take a close look. Tell me your favorite. I don't know which one. I love them all. I'm not making this up, by the way. These are ordinary objects. The bird. I want to see what your favorite is. Oh, they're so amazing, right? And the whole point, actually, I'm using this as a premise in a philosophical argument, right? So exactly what Samuel says, a bit creepy how they jump out without intention. Samuel, that's exactly what I'm using this as a premise for, right? I'm making a point in epistemology, the theory of knowledge, about the relation between perception and our kind of hardwiring and so on. And that's exactly the point I'm trying to make. So it's crazy. We have what are called face detection modules. We can't help but see. And pareidolia is its fancy name for this propensity for detecting faces everywhere. So even when I'm doing this class, I cannot help but might turn my double negations into a little face. But going back to double negation, this fun aside to the side, my friends, is that clear? Notice how you can go back and forth here. You can trim off also not and get back to affirmation. If that's clear, type in clear. If you got a question, ask your question. The paper on in part on Immanuel Kant. All right, so this is one we're going to put in the mix over here. That's double negation, right? If you have as a premise P, then you can infer not P, right? Double negation. And notice how I'm choosing one formulation here, but you can also go the other way around, right? If you have a situation where you have not P, and by P I mean anything you want, right? You could also infer P. So again, I'm making a decision here. Got to pick a formulation that we're going to kind of tattoo on this board, but that is it. All right, one more in the mix. Let's have a look at one more. And I've left the easiest one for last. From what we know, we can infer with 100% certainty what we know. That's a no-brainer, right? Saying something a second time doesn't make it any more true or any less false or vice versa. Whatever happened to be the truth of the proposition at one point is still the truth of the proposition when it's said a second time. So basically whatever you want to plug in here, let's say you have what's at the top. Well, if that's over here, if that's true, then clearly you can infer, therefore, escarque, that's true. Same damn thing. Plug in whatever you want, and you can infer with 100% certainty the same whatever you want. And that's going to be an inference rule, actually. It's going to be called repetition, and it has a stupid form. Premise P, therefore P. My friends, is that clear? If that's clear, type in clear. If you got a question, ask a question. Stupidest one, but we're going to put it in the mix because that's a good piece of plumbing. It's this piece of plumbing, right? It's like a straight little piece of plumbing. It's just kind of like what you plug in here, right, is whatever. Out and it goes into the plumbing. Can't argue with that. Exactly, right? It's like, and out it goes. And it's like, you need this piece of plumbing. I would imagine if you're a plumber, right, that is it, right? The argument's right there. So that's what it is, right? That's the argument. It's a valid argument. Tested with a truth table, right? I mean, what would the truth table for it look like, right? Well, it looks like this. P can either be true or false, right? And then the conclusion is what? Well, the conclusion is P, and well, that can also be true or false. And do you detect any leaks? Yes or no? Is there ever a situation where the premise is true and yet the conclusion is false? It's complete leak proof, right? So there you go. You've got yourself a leak proof argument, right? So that's our little leftover here. So here you have it, my friends. These are the 4 moves that I want you to commit to memory this week. Modus ponens, MP, which says I have a conditional. I have as another premise the affirmation of that conditional's antecedent, and that allows me to infer the consequent of the conditional. MT, or modus tollens, which has a conditional, the negation of that conditional's consequent, and that allows us to infer the negation of that conditional's antecedent. Double negation, which allows us to either graft or remove double negations or double tildes. And repetition, which just allows us to repeat something. If it showed up as a premise, it can show up as a conclusion. It's fair game. Those are the 4 inference rules that we're going to have at our disposal. There's obviously going to be more next week, but that's my starter kit for this week. All right. And notice that they're all pieces of perfect plumbing. I've shown you the one of repetition a moment ago, but for all of them, you can make a little truth table, check underneath and see whether or not there's ever a situation where the premises are true yet the conclusion is false. No, they're perfect plumbing. So they're perfect plumbing and they're easily recognizable, perfect for our toolbox. We can get started. Let's do some plumbing here. Let's have a look at this situation. Which inference rule was used? So if you had to replace the following little thing in red here by MP, MT, DN, or R, what will we put? Imagine you have line 1, it says this. At line 2, we say this. And at line 3, we were able to infer from lines 1 and 2. What will we infer? Lines 1 and 2, we were able to infer this in virtue of what rule? MP. Agreed. MP. Now notice what I'm doing right now. This is already going to begin to segue on what our method is going to look like. You have a line, right? And that line is whatever was a premise over here, right? And then you have another line, here's a premise. And then you can, remember, reassemble the Lego blocks in a way that's 100% secure. So line 3 has been reassembled on the basis of lines 2 and 3. So what I'm saying here is I'm noting that I got line 3 by reassembling lines 1 and 2 in virtue of the following inference rule, MP, right? And if you want to see that more clearly, you can imagine we could have some fun and turn them into, once again, Lego blocks. So for those of you who can't see that, imagine let me make myself a box here, right? Imagine I do the following. I'm going to make myself a Lego block over this. And before I make my Lego block, take a close look at what I'm doing. It's not the case that if P then Q. Okay, fair enough. I'm going to replace this with a purple Lego block. Well, if it's not the case that if P and Q is also, I'm going to replace this with a pink Lego block. Here we go. And I'm just going to shrink my little marker here, right? And then what's the consequent, right? It's if R then not P then S. Notice it's exactly identical. So can everyone see that the consequence, the two formulas here are identical? These compound propositions are identical. If you can see that, type in yes. If you cannot, let me know. There you go, right? And essentially what we have is that little modus ponens move, right? If this, then that, this, and that means I'm allowed to sort of combine line 1 and 2 to obtain line 3, right? By modus ponens. Notice these are the same thing, and these are the same thing. Right? And I find the color coding can sometimes let you spot because it can be a little terrifying, right? But we know enough of our zoology to see, I think, that these things are the same thing. Once I box them in colors, folks who had a hard time seeing them, can you see it better now? Does that help? Like those of you who were a little couldn't quite see, can you see that? Same damn thing. You can box it. And once you box it, you can make it an opaque box. Doesn't matter what it is, right? Doesn't matter what it is. It happens, remember, at any scale. At any scale. Let's have some fun once again. Let's do some more practice. Imagine you have the following 2 lines and you want to infer the third line. As a first line, as a premise, you have this. Second line, you have this as a premise. And then you take line 1 and you apply a rule and you get this. What rule was applied? You obtain line 3. I took line 1 and I applied one of my rules. I have MP, MT, DN, and R. R. Repetition. Repetition. Now look what I'm going to do now. I'm going to go over to the main page of our class. I want everyone to go under Course Essentials. Could you please go at the bottom and open up the file I've just made available? It says all 10 inference rules and 5 theorems. Please open up that file and tell me yes once you have it. Because these are new rules, you might not have committed them to memory perfectly just yet. Tell me yes when you've done that. So you go under Course Essentials, that at the top of our Moodle page. I've made available a file. It says all 10 inference rules and 5 theorems. Click open that file. Tell me yes once you have it. I want everyone to go do that. And keep the file open. It's a PDF. Open and keep it open. I want to hear back from everyone, because if you're going to play along, at the beginning, of course, you might not be super familiar with these things, so it's perfectly normal to have a glance. Good. Good. Remember, we're only doing the top four. All right, so you see MP, MT, DN, and R. And notice here what we've done, right? And again, you can kind of see it. Same damn thing. I've taken up what's on line one, and I've just basically repeated. So I'm allowed to do that, right? What could I do? Let's imagine I decided to go and add another line over here, call it line 4, and I decided to take line 2, and I also decided to use repetition. What would I end up with on line 4? What would I end up with on line 4 if I did 2 by repetition? The same as line 2, right? It's not the case that P or Q. Right? Exactly. You got it, Edric. That's exactly what I could do, right? Let's have some more fun, actually. Let's have some more fun, because fun is fun. Let's imagine that line 5, I decide to combine, let's say 1 and 2, and I'm going to combine them, because I can, with MP. Sorry for my writing here, right? Modus bonus. I take lines 1 and 2 and I combine them by MP. Sorry for my commas look horrible. What would I get at line 5 if I took lines 1 and 2 and I combine them with MP? What would I get? Notice here I'm going to help you kind of see the pattern a bit more, right? I have this over here. Actually, make it easy. What color would I end up with at line 4, given the colors we have now? So imagine I've got green, purple, and blue. What would I end up with? So you don't have to retype. You folks have retyped really well with purple. Exactly. I'd end up with the same damn thing, right? So what folks have written. It gets a little complicated in the chat bar. So, but obviously when we're going to be typing on the on Word, we're not going to have that problem. Good, good. Well done, folks. All right, let's do some more practice. Which inference rule was used? We have line 1, we have line 2, and then on line 3, we recombine lines 1 and 2 by which inference rule? And now you can have a look at your summary sheet. We have MP, MT, DN, and R. Good. Good. Does it help to have the sheet open? Because this is brand new, right? Was that helpful? Because I got a sense that folks, it might help them a little bit if we had that file. Don't be intimidated. There's more on it than you need right now. Okay, so cool. All right, glad that helps. Because, you know, at first you're like, God, I don't remember. What was that one called? What's it look like again, right? And it's okay to have it at the beginning. So that would be empty. Let me just pause right now. What we're looking at right now on the screen, is that clear, everyone? If that's clear, type in clear. If you're lost, type in lost. We have 2 premises, 2 lines with some contents that we've subscribed to. We've agreed to say yes to line 1. We've agreed to say yes to line 2. And we want to recombine this with perfect plumbing so we can say, what else can we say with yes certainty, right? MT. All right, let's have a look. Good. I'm glad everyone's good. Let's have a look at this one. Fill in those 3 question marks for yourself. Take your time. And don't look at the chat. Take your time and do it on your own. How do we get line 6? Which 2 lines did we combine by which inference rule? So what I need is 2 numbers and the code for a particular inference rule. That's what I need from you. The first 2 question marks are numbers. And I need 2 numbers from you, 2 numbers, and the inference rule that we use to combine them. Which lines did we combine and by which inference rule in order to get not S? Do it on your own. Try to do it on your own without looking at the chat. So I need 2 lines and an inference rule. So in the very, you're halfway there. You give me some lines. Which inference rule? and type it just with the commas, right? Yeah, kind of like what ignore just did. That's what I would want. You look at lines, folks are saying 2 and 5. 2 and 5. Let's look at 2, right? 2 and 5 is a conditional. I mean, ask yourself, what animal is this, right? 2 and 5 is a conditional. 5 is the what? It's the affirmation of that conditional's antecedent. And what we end up with as a conclusion is well, it's not the same shade of blue, is the consequent, right? So you have this over here. 2 and 5, 2 and 5 by MT. And that's how we're going to note these things. So 2, 5, and by MT. But let me look at the color coding right now. Can everyone see it now? That's how we got line 6. If that's clear, type in clear. I want to check in with everyone. If you're lost, type in lost, which is no big deal. We'll go over it until it pops. Got to pop. 2 and 5 by MT. That would be the correct answer, right? 2 and 5 by MP. Did folks say MP or MT? I'm looking over the I'm scrolling up. Again, I wasn't paying a ton of attention. I got some MPs in there. No. Is this MP or MT? What are we looking at right now? An MP or an MT? What are we looking at right now? MP or MT? Folks, I mean, MP. I just caught this. I just noticing I wasn't paying close attention to the chat because I'm multitasking with all this color coding stuff. We're looking at an MP. Sorry, folks, you let me get away with this. I'm just kind of taking your lead in the chat, but I'm kind of just so focused with my color coding. We're looking at MP. We're having the affirmation of the antecedent yields the consequent. That's MP. Can everyone see that? I shouldn't have caught that. You should have caught it yourself. MP. Can everyone see that now? Let me once again ask if that's clear. The MT thing was a mistake. If you catch folks making a mistake, including myself, right, scream it out in the chat, right? Why are we looking at an MP, Edric? Why are we looking at it? Someone answer. Why is this? What are we looking at right now as an MP? Why is this an MP? A modus ponens. How do we get line 6 by an MP? We affirmed the antecedent. Right? Again, color coding I feel like is the best thing. Look at this content alone, Edric. And look at this. Is this same or different? Notice any differences, or is it exactly the same? Again, you have to trim the square brackets out. Same damn thing. Yeah, same without the brackets. And you know that the brackets are only there because in 2, this particular compound proposition is embedded inside a conditional. It got swallowed up, right? And likewise, Edric and everybody else, and I'm glad you're asking, Edric, because I'd rather be extra clear, especially since we made a little typo there and I wasn't paying attention, right? What's that? That's the consequent. Right? Well, what's the form of MP? The form of MP is, right? Well, actually, I'm just going to go ahead and make this actually the same color, just so that we're 100% clear, right? I love that. All makes me happy, right? The form of an MP is this, and again, I want to use the color coding. If P, then Q, and Q over here, and I'm going to use my black. Sorry, folks. Good. Yes, exactly, right? This is the form of an MP. If this, then that. We have the affirmation of the antecedent, and we can now infer the consequent. Edric sees it. Can everyone else see it? Type in yes if you can see it. I'm using the colors here, hopefully, so that it pops. I'm busy multitasking here with lots of visuals. We still have lots on our plate, but this really needs to kind of, Well, I think we'll leave that one for the recording, Isabel, and you can have a look again, and we've got some more examples. We'll just move on. No problem. You're looking at, you got lots of materials to work with. Actually, Isabel, I'll just make a little pause here, right? Look at what you have over here. My original question was, how the hell did we get line 6? Were we extracting line 6? Well, look, we were extracting line 6 from the materials above. The materials above are what we have to work with. Remember the goal. Let's go back to our goal. And maybe it wasn't apparent when we originally sort of said this, right? Our goal was to, let me just go back, find ways of reassembling what we know into what, so this is what we know, right? These are the basic building blocks, and we want to figure out this stuff, right? We want to go from what we know, Isabel and everybody else, right? And we want to figure out what we can infer with 100% certainty from what we know. These are the materials we have to work with, and we want to know if we can reassemble them, and we have 4 ways of reassembling them into something that would be 100% secure. Like this would be 100% secure, right? So we go back to where we were, right? And this is one of the moves that we know, right? So these are the moves that we've acquired. Let's go back to where we were a moment ago. Again, this is kind of a recap, but Isabel asked, and I'm doing this for everyone's benefit, these are the moves that we learned, right? These are moves that are ways of reassembling things that we know are both valid and easy to spot, right? From whatever, you can go to saying whatever, right? All of these are valid and easy to spot. MP, MT, DN, and R. And so now we get to the point where we want to deploy all this stuff. We know it's perfect plumbing, right? And we get to where we were. Let me get back to where we were. And Isabella, it's no problem. I'm really happy to do this, so no worries, huh? It's perfectly fine. Yeah, no problem. And so here's the blocks that we have to build with. So look, now all this to say, Isabel, that we have all of these Lego blocks at the tops. Lines 1, 2, and 3, and 4, and 5 we can take to the bank because they're premises. We're going to have materials to recombine. You can't recombine if you don't have materials. Fair enough. Now we want to recombine these basic materials into line 6. Well, how the hell did we get line 6? Well, we got line 6 by doing the following. We took the materials at lines 2 and the materials at lines 3, and we combined them by modus ponens. And we're able to do that because if you'll notice here, right, this is exactly at line 5, we're affirming exactly the antecedent of that conditional, and that allows us to infer the consequent of that conditional, and that's how we got what we got over here. Isabel and everybody else, is that clear? And I was happy that you asked. I'd much rather we just take the time to do that, right? And if you're still lost, and you can tell me lost, but this is gonna shimmy into place. You don't need perfect clarity at the beginning. It's okay to start and it's like, it'll shimmy into place. Let's have some more fun. All right, same idea. Imagine we have lines 1 and 2 as our premises. How the hell did we get line 3? And how the hell did we get line 4? Remember, we need at least some lines and the inference rule we used to combine them. So what I want is this over here is going to indicate which lines you're referring back, and you can help yourself to the materials at the top here, right? And then by which rule did you combine them? How do we get line 3? Let's start with line 3. How the hell did we get line 3? So one thing at a time, because this is all sequential. How do we get line 3? We took 2 by dn. Agreed, everyone. Kelly, Hannah, everybody else. We took 2 by dn. We grafted a double mustache on it, right? Not. We took lines 2 and we did not. Can everyone see that? Type in clear if that's clear. That move, just how we got line 3. If that's clear, type in clear. Just one thing at a time, baby steps. Took 2, and we said, well, if you agree to that, then clearly you have to agree to not that. It's like double Borat, not. All right. It's like you can do it like because Borat says not, right? It's like, well, not. That's going right back to what we said earlier. Exactly, full circle. Okay, cool. So now we have 3 lines that we can play with. Lines 1, line 2, and line 3. How the hell did we get line 4 now? Jaspreet and Gersharanjit, you're wrong. Have a look again. MT. Folks are saying MT, but which lines? Lines 1 and 3 by MT. And again, in order for this to be apparent, often it helps, at least at the beginning, to color code this stuff, right? Notice here, and I'm putting my box at the exact careful spot here. I'm trimming between the 2 mustaches. What is line 3 saying? Line 3 is saying not the consequent of line 1. Let me repeat. Line 3 says it's not the case. This is the first tilde. And then what do you have in the purple box? The consequent of line 1. It's not the case that the consequent of line 1. Can everyone see that? If that's clear, type in clear. If you're lost, type in lost. That's what line 3 is saying. It's not the case that consequent of line 1. Like I'm having a conversation. I say, you said that I would have cancer. Well, I don't have cancer. Sorry, I don't have cancer. You said if I smoke, I'll have cancer. Fair enough, but I don't have cancer, right? And so what you end up with, if I negate the consequent of a conditional, I can infer the negation of its antecedent. And again, look at your summary sheet, right? I can infer the negation of its antecedent. And notice here how I have the negation of the antecedent. I have the negation of whatever was in blue. Right? There you go. My friends, is that clear now? Can everyone see that? Those moves? So we had some building blocks and we build and then we build from building. And if you played with Lego, that's the main idea, right? Reassembly. Some assembly required. It will get complicated, Jaspreet, guaranteed. That's for sure. But it's not, it's still within range that you could see this, right? Remember, the goal is we want to make these things so that they're of a size that we can detect. Jaspreet, do you agree that if I make this box opaque, it doesn't matter what's inside the box? Like imagine I make this instead of, you can see the contents of the box. Can you see it better? Like if I just go ahead and do this, right? And I've got lines 1 and it tells me this. And likewise, I can go ahead and I can make this box opaque. Remember, it doesn't matter what's the antecedent and the consequent. It can be something compound of any size. Earlier, I mentioned at an extreme, a book, right? Like you could have any consequence. Just reading everybody else, can you see that more clearly? Those are Lego blocks. Like I taught you how to reassemble them. Now, the interesting part is you're just going to have to contend with the fact that you're able to spot these relations. Doesn't matter. You can see the inside of the box, right? But the relation is the same. The relation scales. It scales. If this worldview, then that worldview. Not that worldview, then this, not that worldview. Like you can have things of any size. Let's have some more fun. Let's do some derivations now. So now you know the basics of how to do this kind of stuff. And I'm going to show you a way now of proving arguments, right? Of deriving the conclusion from premises in a systematic manner. That's what we're going to do. That's what derivations are. They're a way of deriving the conclusion from premises in a systematic manner that's provable and demonstrable at each step. Can everyone see a file right now that says, let's say, what word have I selected? Let's verify if we can all see that well. So I like that I did a little detour at the beginning to remind ourselves what the goal of today's class is. We want to find ways of reassembling what we know into further things that we can also know with 100% certainty. There's going to be 3 ways of doing that, 3 strategies. And one of the strategies, which is the most obvious one, is the strategy of direct derivation. We're going to abbreviate that one DD. A lot of jargon that you're going to have to learn. It's not that many, but you'll have to figure it out. It's not the end of the world. Direct derivation, much easier to type DD. And here's the strategy in a nutshell in ordinary English. And this is one of the files that you'll have to reread again. So I'm going to go over it, but this is part of your homework. You'll have to go over this, so it'll be dense. It's everything that needs to be said is said, but said tightly. Look, imagine you have an argument, and the argument says that the conclusion follows from the premises. Fair enough. That's what arguments do, right? They say that the conclusion follows from the premises. Well, fine. Let us combine those premises to see if we can indeed obtain the conclusion from them. So let's see if we can actually obtain or derive. You might want to put that word over here, right? Let us combine the premises to see if we can indeed derive the conclusion from those premises. That's how it looks. Here's an argument. If P, then Q, first premise. Second premise, not Q. Conclusion, P. This is an argument that someone's made, and we want to verify whether or not it's in fact a good argument, right? If it's valid. And one of the things that's going to happen this month is we're only going to be dealing with valid arguments, because the method I'm teaching you is not powerful enough to establish whether or not an argument is valid or invalid, but it is powerful enough to give you a paper trail for proving that a valid argument is indeed valid. And importantly, it's going to prove it in a way that's closer to our reasoning processes. It's going to resemble human thinking a little bit. Let me just do a quick sample. Did anyone ever reason like a truth table ever in their lives before you learned this? Like really think of all the possible worlds and then sort of catalog them all exhaustively and then track whether or not, did anyone ever think that way normally in ordinary thought, like a truth table? Like, be frank. Like certainly maybe for maybe a couple small scenarios you can have, but no one thinks this way, right? It's like you have to write that stuff down and learn it in school, right? But you don't think this way. This is going to represent a way of thinking that's a little more obvious. Like someone says P, fair enough. And we're going to say, why P? Well, they're going to give us some reasons. The first line is always going to be the thing that the person said that they're trying to prove. That's their conclusion. And what we want to do is we want to show that conclusion. So I'm going to type over here, show, and I'm going to plug in P. So what I'm going to do is I'm going to just basically, I report back this argument into this grid. That's the first line, always a show line. And notice it's called assertion. Why? Because they just, at this stage, they just said P. Talk is cheap. Back it up, my friend. Kyung, why? Why do you say P? Well, they're kind enough to give us two reasons. One of the reasons is that if not P, then Q. And the other reason is that not Q. So those are two reasons that they gave us. Reason is a colloquial term for premise. They gave us two reasons for why we should accept P. This is the basic materials we have at our disposal to work with. And we want to go, can we recombine lines 2 and 3 to show P? Well, let's see if we can. One of the moves that we have at our disposal, we have the following moves. Let me go and sort of remind ourselves the rules that we have. We have MP, we have MT, DN, and R. And I'm going to do this one for you. Let's imagine I take lines 2 and I take lines 3 and I combine them. How can I combine them? What's one way of combining line 2 and 3 that I'm allowed to do? MT, I can do that. I can't do an MP because if you look at your summary sheet, MP involves the affirmation of the antecedent. Here's my antecedent. I don't have the affirmation of my antecedent. But MT over here involves the negation of my consequent. Well, again, if you can color code this, notice what we have. That's my consequent, right? So I have here the consequent on line 2, and I have on line 3 the negation of my consequent. Well, what is that going to give me? Well, if I negate the consequent of line 2, I end up with not P. Everyone verified that line 4 was correctly obtained by combining lines 2 and 3 by MT. Type in yes if I got it right, no if I made a mistake. I take lines 2 and 3 and I recombine them and apply MT. And that leaves me with line 4, not P. Spot me here. Proof me. So far, so good. Everything is good? Yeah. And Edric says, look, it's the double negation of the first line. Exactly. Well, now you can see the next move we're going to do. What were we trying to do? We have a goal. We want to try to show P. Fair enough. So I'm going to take line 4, and I'm going to use one of the 4 moves that I'm entitled to use, namely in this case, negation. Double negation. Multitasking here. There we go. Double negation. And that allows me to get what? What am I going to get here at line 5? If I take line 4 and I apply dn to it, what do I get at line 5? I get P. I get P. So I was able to show what I wanted to show. So what I'm going to do is I'm going to cross show over here to show, hey, I've shown it now. How did I show it? Over here, I'm going to put how I showed it. I showed it by using direct derivation, or DD. I was able to combine the premises to see if I can indeed derive the conclusion from them. So I was able to show, I want to keep myself my receipts. I'm going to say over here, hold on, I'm just going to remove these extra delete cells, extra columns, so everything fits. On. There we go. Auto fit window. There you go. I was able to show what was merely asserted earlier is now shown, and I was able to show it using direct derivation. And here's my trail of receipts. I don't need these rows anymore. So I'm going to go ahead and right click and delete cells, delete entire row, right? And then I'm going to go ahead and do a little bit of stylistics here. I'm going to remove the stuff I don't need, right? Which is the rows below. I go over here, I go borders and shading. This was a kind of the scaffold that I'm going to remove. So I'm going to just go ahead and remove all these things. You're going to get familiar with playing with tables. This is just a regular table on Word, right? I remove all the lines around, and underneath my show here, I'm going to put walls around all of this, and I'm going to box it in. And this is going to be how I was able to show P. The story for that is going to end up in a box. So once I've successfully done my direct derivation of the conclusion, I cross, box, and annotate. I'm going to sing you a song. Cross, box, and annotate. Cross, box, and annotate. Cross, box, and annotate. So it goes in your memory, right? You're going to always remember this song because I'm going to sing it all throughout the month. And what you do is you cross, you box, and you annotate. That is, you cross to show that you showed the damn thing. You box to show how you showed it. And then you explain what exactly was the type of proof that you found in the box. In this case, a direct derivation. And what you have here now then is the derivation of the conclusion. You have a full proof with receipts, how the hell you can actually prove the conclusion P on the basis of these starting materials or premises. And that's your paper trail. And if you do a little bit more cosmetic, you can shade this, and you'll see this in the homework solutions. I tend to shade this, you end up with this, right? Line by line, you have, oh, how do I show P? Well, here's how. Here's the whole proof underneath. You start with your premises. Then you combine the first two lines, the lines 2 and 3 by MT, and then you combine this, and look, you got exactly what you wanted to show. And that will be a direct derivation of that. This is what you're going to have as a question. This is what you're going to be producing as a solution. My friends, this is a lot to take in, but is it clear enough? Type in clear if it's clear enough, lost if you're lost. A lot to take in, I told you, but clear enough for starters, right? You're going to have all week to work on this. Yeah, and you see, I love what Edric just said. I see the logic behind the gesture. One of the cool things that this does, I won't go into the philosophical details, but what I'm teaching you right now are called systems of natural deduction. The thing is, contrary to truth tables, that we're going to try to hug the contours of our psychological and discursive lives a bit more closely. We want to try to sort of mimic a little bit more how we normally reason. Well, how do we reason? Well, someone makes a bold claim, and then we say, fair enough, man, but talk is cheap. Back that shit up. Show me. Okay. And then they give you reasons. And those are your reasons over here. And they go ahead and they tell them. And those reasons by themselves have to then often be recombined in order to prove the starting claim that the person made. And these are the steps of that proof, right? And that's a really powerful tool because it is both logical and also there's a psychological virtue to them that they mimic a little bit more how we reason organically. Edric, does that make sense? That kind of captures, I'm riffing on your comment, which was a great comment. Right? You can kind of see the logic behind the gesture, you know. And I also notice how they're sequential, right? You can only presuppose what's the lines above, right? At step 4, all we had was what was available over here. And notice, importantly, that before you show something, let me use my eye of Agamotto here. This is my undo button. Before I cross, box, and annotate, cross, box, and annotate, cross, box, and annotate, you will always remember, right? Before I cross, box, and annotate, and I actually showed it, I hadn't shown this line. This is not a line that I'm entitled to use. An uncrossed show line cannot be used because you haven't shown it yet. This is exactly what you're trying to prove. You can't assume the very thing you're trying to prove, right? And so until it's been crossed, you cannot use lines 1. The only lines that you're entitled to use here are lines 2 and 3. Once you cross a show line, it's now thereby shown, and you could keep going, and it would be available for use. But an uncrossed show line cannot be used. I repeat, an uncrossed show line cannot be used because it's precisely you haven't paid for it yet. It's just talk is cheap. Let me show you now. Remember, When you succeed, cross, box, and annotate in that order. And also you can shade for extra visual clarity. Certainly I do so as well in my solutions because it looks clearer. And you'll notice one of the things that we're going to find out very quickly is you can have proofs within proofs, so derivations within derivations, boxes within boxes. And when those get complicated, the shading is going to help you visually sort of sort out what's containing what and vice versa. So shading is going to be a powerful tool for us. All that you're looking at right now, remember, everything's being recorded. And moreover, you're going to have this as a file that you need to study this week. So don't worry, you can reread this file. All right, here's another strategy. This is now the strategy of indirect derivation. So earlier we had DD or direct derivation. Now we're going to have ID or indirect derivation. Here's a one-page summary of it. A valid argument with two premises necessarily has a true conclusion. I'm saying something you already know. That's what validity is. Well, in that case, keep those premises as they are, but assume that the conclusion is false. A valid argument will resist this, so you should eventually obtain a contradiction. And be sure to put the two contradicting lines in red. Read this one more time. A valid argument with true premises necessarily has a true conclusion. That's what validity is. It carries over the truth of the premises over to the truth of the conclusion. Fair enough. Well, in that case, keep those premises as they are, but assume that the conclusion is false. Push back a little bit, right? A valid argument will resist this, so you should eventually obtain a contradiction. Let me show you concretely what that means. Here's the same argument. We shown a moment ago, and you could do a truth table, but now you're learning new tricks, right? We've shown a moment ago that it's valid. We were able to prove it. Here's the proof with receipts. Here you go. We know that this argument is a valid argument. Well, now we're going to prove it a different way. We're going to prove it with indirect derivation. So notice it's the same setup. I'll give you this grid. The grid has more tools, more rows and columns than you need. I get it started. You have an uncrossed show line. Are you entitled to use the contents on line 1 if it's an uncrossed show line, yes or no? No one paid for the claim P yet, so you can't use it. It's just bold. It's talk is cheap. You can BS, say whatever you want. Hey, I can bench press 700 pounds. Does anyone believe me? You'd be like, well, I want to see that. Right? It's like until you've paid for your claims, they're just BS, right? That's a technical name in this class, right? So BS, right? That's another abbreviation. So this is BS, right? Right now it's just another way for BS. It's just an assertion. You just spoke, but you haven't actually backed up what you've said. And you want to try to show P. And once again, you give the same damn two reasons, namely this and namely that. Those are your starting materials. Now, I've said a moment ago, you can't use line 1. So the only lines that are available for you to recombine are lines 2 and 3. Let me pause with this basic setup. This is what you get when you start your homework. Is that basic setup clear, everyone? If that's clear, type in clear. If you're lost, type in lost. That's the starting condition. And it's okay to be lost, in which case we'll try to unpack it. Maybe it could take 2 seconds and you'd be back into the clear category. Yeah. All right, so those are our starting conditions. Now we're going to try to prove it indirectly. Well, what did I just say? Well, keep those premises as they are, but assume that the conclusion is false. So we're going to try it differently than DD now. We're going to use it ID. All right, keep everything as it is, but assume that the conclusion is false. I'm going to take these premises. I'm going to move them down a little bit. And I'm going to go over here, and I'm going to assume that the conclusion is false. If I say that my conclusion is P, what would it mean to say that I'm assuming the conclusion is false? What would I put? If I have P, what would it mean to assume that it's false? It'd mean not P. Exactly right, Anna. Not P. Now notice here in my annotations, everything that's on this side are my annotations. I'm going to say something different here. This is going to be an assumption. And it's not any kind of assumption. It's an assumption that's allowed in virtue of, and again, sorry here, I'm just going to remove a couple needless columns. I'm giving you the starter kit just like the homework, right? But auto fit window, there you go. Here I'm just going to assume that the conclusion is false. Notice it's not what's actually said, but it's an assumption I'm making in the course of my argument. And that assumption is permitted by indirect derivation. Let's assume for the sake of argument that it's not what you say. So you said P. Okay, fair enough. Let's be the devil's advocate. Let's assume here that it's not the case that. And notice the goal. if this was a valid argument, well, if I assume that the conclusion is false, the argument should resist this, and I should eventually obtain a contradiction. So the goal is now, let's see if someone who were to disagree with this argument would be cornered into a contradiction. Let me say that again. The game now is, let's see that someone who would deny the validity of this argument, that is, accept its premises yet deny its conclusion, let's try to see if they would be cornered into a contradiction, into contradicting themselves. Well, okay, fair enough. Now we have lines that we can manipulate. I said we can't touch line 1 because it's an uncrossed show line. We haven't paid for it. But I did make an assumption. I'm entitled to make an assumption in virtue of indirect derivation. So now I have 3 lines that I can actually manipulate. Lines 2, lines 3, lines 4. I want you to look carefully at this, and I want you to think of the inference rules that you have at your disposal. You have 4 of them: MP, MT, DN, and R. Do you see a way in which we could recombine some of these letters and apply an inference rule? Does anything pop out? What could we be doing here? Lines what and what by what rule? What could we do that could generate new materials for us? We want to try to generate more materials now, start playing Lego. We want to recombine these materials. Folks are saying 3 and 4 by MT. Yeah, we could do that. 2 and 3 by MP. Let's have a look here. Imagine I'm going to color code them a little bit so we can kind of see. Let me color code this a little bit so we can see. We got possibilities. Anna says 3 and 4 by MT. Ignor says 2 and 3 by MP. Folks, take a vote. What are you going to go for? MT or MP? Both could be done, I think. What do you want to do? We're trying to figure out what to do here. Make a vote here. MP if you want to try MP. MT if you want to try MT. Put it to a poll. I think both we could do. I'm getting lots of votes for MT. Tell you what, we're going to do both in a sequence because I think we can do both. What would it look like to take lines 3, and notice I'm going to note them in the order in which they appear. Line 4, that should be 4. Line 4 by MT, what should I end up with? If I take lines 3 and lines 4 and I combine them by MT, what should I end up with? At line 5. Not B. And again, I'm going to keep the color coding here so that everyone hopefully can see that clearly, right? This is what you get if you negate, notice this is negation, if you negate the consequent of line 3, you thereby can yield the negation of the antecedent of line 3. My friends, can everyone see how we got line 5? Type in yes if you can, no if you cannot. I want to hear back from everyone. I want to teach everyone to make sure everyone's good. Good. And look, this is terrific. We just generated a new Lego block for us, right? We have more stuff to manipulate. I'm going to have some fun also. Earlier, there was talk of an MP. If I do lines 2, line 3, and I combine it by MP, what do I end up with? Look at line 2 and line 3. I have a conditional. I have the affirmation of that conditional's antecedent. What do I end up with? I end up with Q. And again, I'm just going to color code this. I won't do this forever, but I feel like the color coding helps a little bit. My friends, let's check in with everyone. Can everyone see how we managed to generate the content of line 6? Good. Now, let's take a pause here. Let's take a pause. What are our live lines? What are the lines that are entitled to manipulate? Well, we have lines 2. Let me just put all this back in black. We have lines 2, 3, 4, 5, and 6. And remember, our goal was what? Let's go back to our goal. Let's assume that the conclusion is false. If it's truly an argument, then we should eventually obtain a contradiction. Let's have a look. have we obtained a contradiction? Are we contradicting ourselves somewhere in here? Are we talking against ourselves? Like everything that's on the record here are things we've said yes to. Are we saying yes to both one thing and its contrary? Do we have a contradiction somewhere? If so, which lines? Lines 4, exactly. Lines 4 and 6 contradict. Notice this. On the one hand, you're saying not Q, and here you're saying Q. No problem, Hannah. It's like, well, which is it? Which is it? I cornered you into a contradiction. Are there any further contradictions? Does anybody see any other further ones? Two and 5, agreed. Look, you said earlier, I heard you. You assumed not P, and look, you're saying now not P. You're contradicting yourself. I mean, let's have some fun if you want to see that even more clearly. Let's apply 5 by dn. What do we get if we take line 5 and we manipulate it by dn? What do I end up with here? P. That's clearly a contradiction, right? You said not P, and now you're saying P. Well, which is it, bro? It's like the earth is flat, the earth is not flat. You're talking all over the place, bro. What's wrong with you? I caught you committing a contradiction, right? And why? Because you're denying a valid argument. If you assume the negation of its conclusion, if you deny the conclusion, you're caught in a contradiction, right? So we're going to pick one of these contradictions. We're going to keep it in red. I'm just going to keep this one over here. Actually, we could go back, right? Let me just go back and use my my Eye of Agamotto here, right? I'm going to put this, and I put everything back in black here. I'm going to keep this contradiction here. Just keep it nice and trim. And we say, I gotcha. And then we successfully did. So we cross, box, and annotate. Cross, box. I'm going to remove everything here, all of these. Tuk, 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 tuk. And then I can reselect. Notice how when I move my cursor, you can kind of feel there's a, can everyone see when I move my mouse, there's a little lines that appear all of a sudden when I kind of move over an imaginary line for the grid? Can everyone see that? You see my little, can people see my cursor change? So the grid's still there. It's just not visible, right? So I click and drag, and notice here, you can see they're kind of still there. I'm going to, actually I have a row too many here, so I'm going to delete this row, delete this needless row, because Papa Bear gave you more than you needed to work with, it turns out. I'm going to box all of this because it's cross box, so top box, bottom, left, right, box the whole thing, and annotate. How did we prove this? DD or ID? How do we prove what's in the box? What method did we use? ID. ID. And notice here, put the two contradicting lines in red. I want those two contradicting lines in red so you can visually, I can know exactly where the contradiction occurred. So if you had to paraphrase in normal English, someone made a valid argument. Okay, well, because it's valid, you have to accept the conclusion. You want me to prove it? Fair enough. Deny the conclusion. Let's see what happens. Well, if you deny the conclusion and you accept the premises, you're going to eventually catch yourself committing a contradiction, which shows that this thing is actually following from the premises. That's what's happening. And notice how this tracks normal reasoning a lot more than, let's say, a truth table. There you go. That was ID. Let's pause. And again, clear enough because you're going to practice on this all week. But are we clear enough, folks, or do you have a question? Type in clear if you're clear enough. Question if you've got a question. And I'm happy to hear questions. And Samuel says, can we use the assumption ID even though it's not paid for yet? That's absolutely yes, you can. Yeah. And Edric, do not look, because I let you open that other file, do not look at the other inference rules. So don't look at those at all. Right? That's just for, you look at the ones we're working on this week. Yeah. So Samuel, yes, the whole point of making the assumption is to use it, right? Otherwise, what's the point? Right? So yes, it's a live line. So the answer, Samuel, is yes, it's a live line. Assumption, and it can be discarded. Yeah. I mean, it was for the sake of argument, right? So let's imagine, so for instance, if I say, Samuel, if you were 9 feet tall, you wouldn't be happy. Really? Oh, so here's why. Let's assume you're 9 feet tall. And then I go ahead and I prove my point. I need to sort of assume for the sake of argument that you're 9 feet tall. You're not 9 feet tall, but let's just go there for a moment. And once I've proved my point, it's an assumption I can discard. It proved what I had to prove, right? But for sure, in order to prove my point, I need to make use of the assumption that I've just made. Right? So let's assume for the sake of argument that, and then blah, blah, blah. And then you can totally use that. And that's a move we do all the time. Yeah. Ignore says, so the purpose of ID isn't to prove the conclusion, but to find contradictions. Yeah, kind of. To establish the validity indirectly, by extracting a conclusion from its denial. Let me say that again, ignore, because that's really technical, but I think I've said it accurately. The goal of an ID is to prove the validity of an argument by showing how the denial of its conclusion leads to contradictions. Ignore, does that make sense? Yeah, it's amazing. And you think about that move, right? I'm teaching you karate. I'm a philosopher. If I make a valid argument, it means if you don't agree with the conclusion, then you're an idiot. You're going to contradict yourself. If the premises are in fact true, you agree to the premises, you have to accept my conclusion. Otherwise, you're going to talk against yourself. Contradiction just means talking against yourself. Contradictio. Here on the one hand, you're saying the negation of Q, and here you're saying the affirmation of Q. Well, which is it? Right? It's like, well, God exists and God doesn't exist. Well, dude, I'm sorry, but you're all over the place, right? It's one or the other. And so if I catch you, if I corner you into committing a contradiction, right, as a result of our conversations, then that's the hallmark of irrationality. A valid argument is one that must be accepted, provided its premises are true. So if I get you to nod yes to this premise, and I get you to nod yes to the second premise, you have to nod yes to the conclusion. Case in point, let's imagine you nod no to it. Let's see where that goes. And look where it goes. Nowhere good. Another gloss on that, ignore. Did that gloss make sense? And again, it's nice that I can make these glosses on this stuff, these interpretations in ordinary language of what it is exactly that's happening, right? That's the paper trail. Yeah, cool. No, you can't get a contradiction through DD. No. The method with the contradiction stuff, Hannah, is only the ID. Yeah. And you wouldn't get a contradiction because these are all valid arguments this month. We're only looking at valid arguments. An invalid one would obviously land you into contradictions. Yeah. You could have, and I would do a quick aside though. If you have the following, we'll find out. I'll teach you this maybe in a couple of weeks once we know a few more tools. But if your premises are this, actually, let me just kind of let me remove this. Imagine that you have the following, and Anna, this is because you're smart, and I'm having an extra round with you. Imagine that you have these are your two premises, P and not P. You can buy any conclusion you want because you're contradicting yourself in your premises. We'll find out how the shit hits the fan and you can do basically whatever you want. The moment you're contradicting yourself, it's going to have funky consequences that we can explore next week. They're bad, and I'll show you why demonstrably they're bad. Yeah. Okay, so let's have a look at our solution. Here you go. This is what it looks like when it's all nice and neat. This is what you would find in the homework solution this week. I shaded. By the way, if you want to find out how I shade this stuff, you select the whole box, you right click, this is on Word, could be different on your software, borders and shading. Then I go over here on shading. Borders is where I put the top, bottom, left, and right side of the box. And I go here and I shade it. Oh, I believe I do 10%. Am I right? 10% shading? Yeah, that's the right shade. 10% shading. Just enough. If it's more than that, it becomes a real pain. So please, everyone, let's agree that we're going to shade it 10%. Like this would be, like this is too dark. That's really annoying on my eyes, right? And the idea is that's going to allow us to see more clearly some of the stuff later on when these things get complicated, because I'm warning everyone, this is just baby steps. These things are going to get obviously much more involved. So now we've discovered 3 ways of proving an argument, of deriving its conclusion from the premises. The indirect method, which consists in supposing that the conclusion is false and trying to obtain a contradiction. The direct method, which is the no-brainer method, just damn straight try to find the conclusion by extracting it from the premises. And now I'm going to teach you one additional one. There's only 3 strategies. It's going to be called conditional derivation, CD. So far, so good, everyone. How are you hanging? How's the energy levels? It's 11:43. I got one more strategy to teach you. Then we're practicing homework. I told you it'd be a big workout. Let me check in with all my people. How are we feeling? We're in the dojo. We're working out. I told you it's arguably the most crucial class of the semester. We're doing good? Food is where I'm actually going to take this excuse to eat another bite to eat. I need energy because I don't want to make mistakes. All right. Here's the conditional derivation. Here's the strategy in a nutshell. The argument's conclusion is a conditional. Well, if it's a conditional, then essentially what it says is, if this, then that. Fair enough, man. In that case, let's assume the this part. Again, assume. Let's assume the this part. Let's go with this. He said, if this, then that. Fair enough, man. If this, let's assume that this, like if you're 9 feet tall, then you'll be miserable. Let's go with it. Let's assume you're 9 feet tall. If, after having made that assumption, we can attain to that part, I show that you're miserable, then we've shown that the conclusion was indeed right. And by the way, I have no clue why 9 feet tall would make you miserable, but I just like, that's what came out of my head, right? This is the idea. Assume the antecedent and try to show if indeed you can attain the consequent. That's the move. Here's what it looks like concretely, right? Now you have three strategies at your disposal: DD, ID, and CD. So which strategy should you use? It's simple. Look at the line that you want to show. That's your show line. If it's a conditional, use a CD. If it's anything else, do an ID. ID, by the way, are more powerful than DD because they're like DD plus they get to make an assumption. So do an ID. So this is Papa's rules for how to figure out which of the methods to use. Look at the line you want to show. If it's a conditional, use a CD. How do we kill an elephant? With an elephant gun. Sorry to break it to you, but when you go on a safari, there's only one kind of gun that shoots an elephant. It's called, appropriately enough, an elephant gun. You come face to face with an elephant, you're hunting, use an elephant gun. It's a no-brainer. It's anything else, use a regular gun, ID. All right, so if it's a conditional, kill it with a conditional derivation. Let me pause here. I know this is fairly abstract, but this is a no-brainer recommendation. Is that clear, everyone? Look at your show line, ask what animal is it. If it's a conditional, use CD. If it's anything else, use ID. Is that clear? Nice comment, Jackson. Yeah. All right, so let's have a look. Zoologists. This is my show line. That's what I want to try to show. Here's an argument. Has a premise, it has a conclusion. I want to try to show what? I want to try to show the conclusion. Here's my conclusion. Zoologist, what animal are we looking at? The one I've selected. It's a conditional. So what method are we going to try to hunt it down with? No problem. A conditional. So what method are we going to use? CD. We're going to use CD, right? Again, no brainer. You want to figure out which method to use? You got three. Follow these simple guidelines. Instead of having a textbook, you have this. Not that complicated to commit to memory. Well, what is the move? Assume the this, try to show the that. Assume the antecedent, try to show the consequent. Because that is what it's saying. If this were the case, then this would be the case. Well, fair enough. Let's assume that this is the case. So I'm going to go over here. I'm going to take my premises, which already been written in here. I'm going to drag them down a little bit, give myself some space to work with. The move of CD is assume the antecedent. Fair enough. Here's where copy paste is nice. Copy, paste. And that is going to be an assumption. It's an assumption that's permissible in virtue of CD, and I want to annotate that. Once again, I'm running out of space. I'm just going to delete this column over here and then readjust my table. Auto fit, window, everything should fit. Oh, no, I still need to delete another column here. Let's just delete another column so everything fits on the page. Here you go. And you can click here the corner. It selects the whole table, which is nice and convenient. You can also drag if you want to select the whole table. Nice and clean, right? Okay, fair enough. I'm going to assume the antecedent of this conditional. And I'm going to try to show, because let's take you at your word. You said, if this is the case, then this should be the case. Fair enough, ma'am. I'm going to take you at your word. Let's assume that this is indeed the case. And now I'm going to try to show that the consequent that you've put forward in your conclusion, in fact, follows. I'm going to try to show this. Now, a show line is a assertion. I haven't paid for it. Assertion, and I haven't paid for it. So I'm just going to keep these brackets here and not write anything in them because I haven't paid for anything yet. I still haven't shown that not Q. Now, look at what I said. It's a show line. You're going to try to have to show it. How are you going to show it? You have three methods, DD, ID, and CD. Well, what did I say? Look at the line you want to show. If it's a conditional, do a CD. If it's anything else, do an ID. Zoologists, what animal are we looking at? It's a negation. Is it a conditional? Yes or no? Is this an elephant? Yes or no? It's not an elephant, so what are we going to use? ID. We're going to use ID. Remember ID, right? Assume that it's false and then try to obtain a contradiction. What would it mean to assume that not Q is false? Imagine I put my ID assumption over here, assumption ID. Ignore says not Q, and Anna and Gersharanjit say not and say Q. The correct answer is not Q. All right, but Papa Bear is going to let you have a little shortcut. The correct answer, strictly speaking, would be this. The negation of not Q is not Q. But for assumption ID and only for assumption ID, I'm going to allow you crazy kids to skip double negation and to just go ahead and put this. Right? So instead of writing not Q, you can just go ahead and put Q. Only for assumption ID can you skip double negation. And that's a convention that I'm going to follow myself in my solutions. And that's a convention we're going to allow ourselves, but only for assumption ID. DN, double negation, is still a move that we're going to have to carefully record in all our other transactions, but only for assumption ID, I'll let you skip that. Is that clear, everyone? That's special exemption. If that's clear, type in clear. If you have a question, ask your question. Just to skip a line, I'm very hesitant to do that, though. Strictly speaking, the negation of not Q is not Q. So Ignore's answer was the superior answer, strictly speaking. But we're just going to agree on this one way of trimming an extra line. Fair enough. So that's my assumption. Now I pause. Remember, I can't use the materials on an unshown show line, an uncrossed show line. So I can't use this, clearly. That's a conclusion. I can't use this, clearly, because it's something I'm trying to show. And I've got these other lines that I can use. I'll call those my live lines. They're the materials I can actually play with Lego. I got lines 2, lines 4, line 5, and line 6 that I can manipulate. Now we're going to start recombining this, right? The last thing I have to pay for is not Q, and I want to try to pay for it, and I said I'm going to try to do an ID on it, right? But right now, just try to generate new contents. What could we do at lines 7? What is it that which lines could we use and by which inference rule to create which contents? Look carefully at our live lines, lines 2, 4, 5, and 6. What could we do? Which inference rule could we apply and on which lines? I'm going to try to generate new contents here. We're reassembling the Legos. What could we do? Lines 2, 4, 5, and 6 are fair game. What could we do? Suggestions. Don't get ahead of yourself. Just say the suggestion and we'll see where it goes. We've got at least one suggestion. Let's have a look. Good suggestions, Jaspreet. Good suggestion, Ignore. We've got lots of suggestions. Let's do a couple. Let's start with Jaspreet's suggestion. Jaspreet says, how about we take 2? No, he said, Jaspreet said 4 in the order in which smallest number first. 4 and 5 by MP. All right, so 4 and 5 by MP would give us what? What would that give us? If I take 4 and 5 by MP, what do I get? I have a conditional. I affirm its antecedent. What do I get? I get not R. Exactly. My friends, proof me. Did I make a mistake? If everything is good, type in yes. If I made a mistake, type in no. Proof my line 7. It has to be perfect plumbing. Type in yes if it's perfect plumbing, no if it isn't. I took 2, I took 5, and I got me lines 7. Beautiful. Awesome. Let's add another row here. Thank you for proofing my perfect plumbing. Insert row below. This will be row 8. Now our live lines. We have lines 2, line 4, line 5, line 6, line 7. We had an earlier suggestion also. What was the other suggestion that I skipped over? Repeat that for me. Another suggestion. Someone said 2 and 6 by MP. I'm just going to write that and see if that's feasible. 2 and 6 by MP should give me what? If I take 2 and 6 by MP, what should I get? I should get R. Anyone notice anything? Yes, Jaspreet. We got a contradiction between lines 7 and 8. They contradict. Yes, we just managed to pay now, because remember our goal was to show not Q. And we said, okay, fair enough. Let's assume let's negate it, right? Let's assume it's negation. And then we will try to corner ourselves into getting a contradiction because we got one. We did it. And so we were able to now cross, box, and annotate. Cross. We're going to box all of this. All right. I'm just going to sort of make a little box here for the moment. It's kind of a subsidiary box so that we can kind of see this box over here. How did we show line 3? What method did we use? How did we pay for line 3? What did we use in this box? What was the move we did? DD, CD, ID. What do we use? ID. I'm going to annotate now how I paid for it. So it's paid for. Here's how I paid for it. And here's the proof. I paid for this. Here's my method of payment. And here's the actual payment. Cool. Now what does that mean? Now it means that the live lines are what? Lines 2 and line 3. And I said that I wanted to show line 1 by CD. And CD was what? CD said, let's assume the antecedent. And having made that assumption, let's see if we can obtain the consequent. Well, what have we done? We've assumed the antecedent and we've obtained the consequent. So we have thereby shown that this claim was actually correct. If you assume its antecedent, you'll actually get its consequent. And we paid for it how? ID, DD, or CD. How do we pay for it? Line 1. We paid for it using CD, conditional derivation, and we cross, box, and annotate. And here you're going to see an example, and it's carefully doctored so that everyone gets a chance to be exposed at least once to these things before I send you in the wild with your homework, right? Let me show you why the boxing is going to matter, right? Here's a situation where, hold on. We have a proof or a derivation of line 1. We were able to show line 1. And as part of that, right, we assumed the antecedent and we were able to show the consequent. Well, how did you show the consequent, Mark? Well, I showed it in the following manner. You have a box within a box. What's beneath the show line is always the box that backs it up. How did you show it? Someone said, if P, then Q. I'm going to show you how. Fair enough. Assume that not P. Sorry, if not P, then not Q. Assume that not P. That gives you Q, not Q. How? Show me. Well, here's how, and I have the proof underneath here. And I've got all of the receipts and all of the paper trail. And when I've done that correctly, I have a correct answer on a quiz. This would be 5 out of 5. Anything other than that would be 0 out of 5. And I go line by line, and I go down, 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 and I can retrace all the steps. And I got my hand near the buzzer, and I'm going to see if there's ever anything that's less than watertight plumbing. What it looks like in the solutions is this. Notice the shading really helps. Shading lets you kind of see more visually which box is within which box. I'm going to pause now, and I'm going to ask how everyone is doing. Report back to me in one sentence, how's everyone doing? So we tried a CD. We test drove a DD, an ID, CD. We've got a good sampler now of what the hell we're going to be doing. How's everyone doing? Is this clear? Type in clear or a sentence of how you're feeling. Question if you've got a question. It's going to get fun too, obviously, right? Samuel has an interesting question. So in CD, the antecedent is an assumption, but then the consequent is an assertion which has then to be proved. Exactly right, Samuel. I couldn't have said it better. Yeah, exactly right. For the sake of argument, you can get the starting assumptions, but then you have to, okay, but the sake of argument doesn't get you the thing for free. You still have to sort of back it up, right? Yeah. And one of the things we do, Edric, is you're going to have to reread this carefully. These are written by me, carefully written, right, in plain English in a way that's not frightening, but you all will need to sort of go over this, and plus in the practice. Remember this advice. Look at the line you want to show. If it's a conditional, do a CD. If it's anything else, do an ID. Right. Here are now some important things that I want to say, and you need to reread this carefully because this is vital. There are only 2 types of assumptions that you can make. The only assumptions that you're allowed to make are a negation of whatever is on a show line, and this assumption has to be annotated as ID and go immediately below the show line. So when you see an assumption over here, assumption, right? Assumption, These are the only kinds of assumptions you can make. So this is one of the assumptions. Assumption CD. The assumption of the antecedent of a conditional, and it goes right beneath that line. And, right, so this is over here, the assumption of the antecedent of a conditional on a show line, and this assumption must be annotated as CD and go immediately below the show line. So here you have two examples. Assumption ID, assumption CD. That is it. There are no other assumptions. Those are the only assumptions that you're entitled to make in this step-by-step method, right? A negation of whatever's on a show line, that would be an ID, or the antecedent of the conditional that's on a show line, that would be CD. Let me pause here and check in with everyone. Is that clear, everyone? Only two types of assumptions, assumption ID or assumption CD. If that's clear, type in clear. Got a question, ask a question. You can't just make up whatever. There are no further assumptions you can make. Very careful method. You can't just buy yourself whatever the hell you want. Otherwise, like, what the hell? All right. Now, the only assumptions where you can skip double negation are which? Well, if you're trying to show a negation, in other words, if you have a compound proposition starting with a not sign, and you there might make assumption ID and the negation of the negation, you're allowed to skip DN and simply put the affirmation of the relevant content below the show line. In other words, you don't have to write not. This is exceptional. It's an exceptional notational shortcut, and it applies only to assumption ID only. DN, or double negation, is still a thing. Is that clear, everyone? What happens, you think, if you skip DN in any other context? What do you think is going to happen? If you skip double negation anywhere else, what do you think is going to happen to you? Yeah, a donut again. Damn donut, right? Yeah, exactly. So this is the only place where you're allowed to skip it, and it's precisely because it's contained that I'm allowing that, right? You can skip DN for this. Now, notice that you sometimes need to do a double negation before doing something like an MT. So for instance, imagine you have the situation. On line 17, somehow, there's no story above. Presumably there's a story. There's 16 lines above line 17. So who the hell knows how you got it? But let's say you got S. Well, in this case, it tells you got it by a premise. So let's just skip ahead, right? You got a premise. And at line 18, you also have this, and that's also a premise. So you just take these things for the starting blocks. This would get 0. If you at line 19 said, I'm going to combine line 17 and 18 by MT, and thereby get not R, this would get 0 because it skipped a step. Whereas this would get full marks. This would be great. Same situation. You have this, you have this, but you take your time. You take at line 19, you say, I'm going to take line 17 and I'm going to do a double negation on it. So you get not S. And then you combine lines 18 and 19 by modus tollens to get your not R. So this would get full marks. This would get no marks. So this is a visual sort of representation concretely of what it is that I just said a moment ago. Is that clear, my friends? If that's clear, type in clear. If you've got a question, ask a question. I don't want anyone losing points for this. It would really suck. Take your time. And notice it's about keeping a paper trail of all of the moves, step by step. Just like we did, everything in this class has to be carefully argued, step by step. Yeah, don't skip anything. Take your time. Take your time. And this is going to be fun, though, because the fun part is, you know, if you got it right, you demonstrably got it right. Yeah, so the top one's in red because red is bad. That's incorrect. The bottom one is green, green good. Exactly, ignore. Exactly. Yeah, top one would be incorrect. You'd get 0. This would get full marks at the bottom here. Now, here's the derivation summary, and that's the last slide I'm going to show you right now. This is a distillation of an entire logical textbook in one page. But if it's compact, but it cuts to the chase. Here's how you do derivations. You can try to show anything you want, although there's no guarantee that you will indeed show it. This is annotated as assertion. You haven't paid for it. So talk is cheap, and precisely for that reason, you can try to show, this is a weird and counterintuitive thing, but this is important. You can try to show whatever you want. You're free to make any claim you want. If you want to say you can bench press 700 pounds, you're free to say it. But you haven't paid for this. You haven't proven it. But it's part of the method that you can try to show anything you want. So at any point, you might get stuck and you might want to say, oh, damn, let's use my Agamotto. Let's go back to where we were, give ourselves lots of stuff. And you might find yourself, let's imagine that you didn't obtain this contradiction and you're stuck, let's say, right? And you say, damn, it would really help me if I had, I don't know, right, this, right? And you can show whatever the hell you want, but you haven't paid for it. And then the thing is, you have to then pay for it. And you can't be done until you've paid all your bills. But you can try to show whatever the hell you want. Thing is, you have to put a box underneath and try to show it after. But this is going to be what's going to separate the good from the sort of not so good, is when you get advanced in this method, sometimes proving the conclusion, deriving the conclusion, is going to hinge on you calling for the correct show line. So you have to be strategic about what you want to aim to show, right? Like, let's say you didn't have Q and you're like, man, it would really help me if I had Q. If I had Q, I could totally do an MP on line 5. Then you try to show Q, right? And then you have to pay for it underneath. You have to have a box that pays for it. Anna writes, each show is somewhat analogous to an entry point in a shortened truth table. No, I don't think that analogy holds, Anna. No, but good try. Good try. Kind of a, no, because the entry points aren't sequential in the sense that these are going to be hierarchical. So the short answer for why I just said no, here's why. The show lines are embedded in one another like Russian dolls. There's a sense in which you have to show this before you can show, you have to show line 3 before you can show line 1. There's a kind of a subsumption relation that wasn't present in a short truth table. Great observation, Anna, though. But close, but yeah. Whereas the show lines, when you're going laterally in a short truth table and you're moving horizontally and you're picking an entry point, you've got some sort of freedom. But the element of freedom is right there, though, Anna. So you're right. There's an element of choice and freedom, but it's actually more freedom because the contents are up for grabs. You see that, Anna? So I get what you mean. You had freedom in choosing your entry points. Now you have the freedom with these show lines where you can try to show whatever the hell you want. You want to show K? Try to show K, right? Like you can show whatever you want. Hannah, does that make sense? Like I think I now sort of see where you were going. There's even more freedom than a short truth table. So it's disanalogous, but for another reason, because you have even more freedom. But remember, back up what you say. Back up what you say. All right, so that's this aspect here. However, a line with an uncrossed show cannot be used in inference rules since you haven't paid for it. Makes sense. Like once, if I haven't yet shown to you that I can bench press 700 pounds, it's not like I get to go around now bragging and using this in some sort of context. Dude, it's still just talk. It's not walk. You got to convert the talk into walk. I want to see some walk here before I get you to have the talk. Same thing. If it's an uncrossed show line, you cannot use it. It's something you want to pay for but haven't paid for. Let me pause so far. Is that clear, everyone, these 2 points? If that's clear, type in clear. If you got a question, ask your question. Once we got all that, then we'll try our homework together. Gotta pay for that stuff. However, once a line's been shown, it can be used. So once you did back up what you had to say, it's been proven. Then you can actually now use that as a premise and recycle it in further inferences. However, all the lines inside the box beneath the crossed show line can no longer be used. So the price to pay for proving something, right, for showing not Q, is that all of this is no longer available for use. Everything that's in the box beneath is boxed and can no longer be employed. Lines 4, 5, 6, 7, 8, once you've shown line 3, are no longer live lines. They're no longer available for manipulation. They end up in a box, a transparent box, not an opaque box, but still a box. You can no longer appeal to them. It's a sub-proof or a sub-argument. I made a little detour to show you that not Q, but that detour can no longer be used. Is that clear, everyone? Type in clear if that's clear. Question if you got a question. And then I'll answer Samuel's question. So Samuel, let's imagine, for instance, right, that I say, Samuel, you're a great guy. So let me put this, Samuel asks, in that case, why wouldn't they still hold, right? And we're trying to sort of understand in normal discourse here, normal conversation, what this is tracking. Samuel, I'm going to try to show you, right, why you're such a great guy, right? And I say, let's say, if a kid would drown, Samuel is a good student of mine. He's a Canadian soldier. Samuel would save the kid. Right? I make this claim. Now let's assume, because I want to prove that, right? Let's assume that the kid drowns. All right, so I'm going to go kid drowns. Kid is drowning. So I'll go drowning as part of my assumptions because I want to back up the claim I just made, right? And then blah, 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 right? And then eventually I say, therefore, and I've proven what I wanted to prove, which my initial goal was to what? Was to prove what? I said if a kid would, I mean, it's like, what am I trying to prove? Right? That Samuel was a great guy. So I say, Samuel is a great guy. Let's say my arguments, the blah, 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 was all persuasive. And I've established to everyone's satisfaction that Samuel's a great guy. Why? Well, because you know what? If a kid would drown, he'd throw himself in the water and do what he can to save him, blah, blah, blah. And I've established that Samuel is a great guy. Now I want the conversation to move on. Can I use that a kid is drowning as part of that further conversation, Samuel? Once I've established that you're a great guy and we're moving on to other things, can I say a kid is drowning? Yeah, you see that, right? That was just part of my proving something else, and I discarded that. Once it served its purpose, that's in a box now. That sub-conversation to unpack the claim that Samuel is a great guy, yeah, it's like, I can't then keep going and, a kid is drowning. That's no longer a thing. Right? That's no longer a thing. And this conversation now just happened in the chat, but I want everyone, does that make sense? Because Samuel was asking kind of a question. I want everyone to feel it in their bones. My friends, did that make sense? Like why I can't keep using the kid drowning thing? The whole point was to make a point, and then I made my point, and it's like, well, okay, we're moving on. It's like, and this is what's cool about this logic we're learning, this aspect of our third month is that it's tracking our ordinary conversations and deliberations much more clearly. Yeah. And the kid he was never drowning. It's not that kid's not drowning anymore. He never drowned. It was an assumption for the sake of argument. Everything I just said was just to prove that Samuel's a great guy. I dust myself off. I've proven it. Who the hell cares right now? All that's a sub-argument that was for the sake of establishing that one thing, right? And then that's all in a box. Yeah. You will often have to build a derivation within a derivation, so a box within a box, and the kinds of derivations they can differ, right? You can have an ID inside a CD, and in fact, that's what we had a moment ago. So just be mindful of that, right? Here's a CD, and inside the CD is an ID. So that's the second to last point. Finally, all show lines must be crossed in order for a derivation to be complete. You got to pay all your bills. All of the show lines must be crossed. And that, my friends, is the method. Let me pause. Do we want to start the homework? Because that's our goal. We want to do the homework. Is that good? Is everyone still good to go? I said we would do some homework, right? We would learn this stuff. We would practice the homework. Let's open up that homework. All right. Everyone still good to go? Let's open up that homework. Hold on. Let me open that homework. All right. I'm going to hold your hand for the homework so it's not scary. We'll do the first stuff together. And here we are. Let me just share screen that. Hold on. Can everyone see first derivation homework? If you can see that, type in yes. All right. This is exactly the file that you're going to find on Moodle as soon as we say goodbye. Derive the following arguments using only the inference rules R, double negation, DN, modus ponens, MP, and modus tollens, MT. So those are the only ones, right? I'm going to go back at the top and I'm going to hide the 10 inference rules because I've got an actual sheet with only the 4 that you're using that's going to be available as soon as we're done class. I urge you to spread the work instead of bunching it, since sleeping nights in between is better when training your subconscious to acquire habits. There are 21 exercises in total, so throughout the week, aim to do 3 derivations per day. Also, be sure to take advantage of your shortcut keys and copy paste. I've reworked everything so that the conclusion and premises are already typed and carved into the boxes. So here's a situation where we have an argument. Here's the conclusion of the argument. We want to try to show that conclusion. We've given one reason to accept the argument. That's our premise over here. Our first order of business. I'm going to do this entire one on my own, and I'm going to narrate the steps I take, and you just follow along. And if you're confused and I say something that you're not understanding, you're going to let me know. Our first order of business is we want to try to show this we're going to have to determine which of the methods we're going to be using, either DD, ID, or CD. And in order to figure that out, we got to know which animal we're trying to hunt. What animal are we looking at? Well, if it's an elephant, use an elephant gun. So we're going to use a CD to do this. What's CD? CD says, assume the antecedent, try to show the consequent. Fair enough. Let me just move all this below. Hold on. Notice how I have to select the whole thing if I want my annotation to go along with it. So cut. I'll go put this over here lower, right? Assume the antecedent, try to show the consequent. Here's my antecedent. Oh, I got parentheses I no longer need. That's an assumption. It's the assumption of CD. And try to show what? Assume the antecedent, try to show the consequent. I'm going to try to show the consequent. And that is an assertion or assumption. A show line is what? An assertion or an assumption? Assertion. And did we pay for it? Yes or no? So far, have we paid for it? Yes or no? No. So we don't put anything in the brackets because we haven't paid for it yet. Cool. All right. So again, same mechanism. We want to try to show something. What do we want to show? We want to show not P. That's a negation. If it's anything other than a conditional, we use which method? If it's not a conditional, what you use is ID. More powerful than DD because it allows you to do an assumption. Fair enough. What do we get to assume? We get to assume its negation. That would be not P, but for this one particular area, we're allowed to skip over double negation. That's my assumption ID. All of this part here is table setting. It's just me preparing myself for the hunt. I've got a premise because clearly I need at least one premise in the mix to get going. It's an argument after all. I need a premise. Cool. What are my live lines? Lines 2, 4, and 5. Then I have to now tease apart different relations between these lines. I'm looking and I'm seeing here that, you know what, lines 2 and 3 could be combined by MP. Notice that I always want you to put the numbers in the smallest number first, and please put a comma after your period. All right, so this would be annoying to me visually. Like when these things get going, it's going to be much easier if we put some spaces. So notice that I say 2, and you're absolutely right, Samuel. You caught me making a little mistake because I'm narrating 2 and 4. Yeah, because 3 is not an available line for me. Thank you, Samuel. So 2 and 4 by MP. What should that give me, everyone, at line 6? If I take 2 and 4 by MP, I should be obtaining Q. Exactly. Hey, look, I got what I wanted to do. You can get what you want. I'm going to delete this over here. I'm basically done. And I'm going to go, that's not what I want. I want delete cells, delete this extra row, cross, box, and annotate. Cross, box, and annotate. I'm going to remove this. I'm doing it fairly fast. Hold on. Cross, box. And I'm going to show you an interesting thing about boxing that's going to be a feature you need to be mindful of. Box, annotate. How did I pay for this line 3? What method did I use to pay for it? ID. I thereby, because I've shown exactly what I set out to do, I said if you assume the antecedent, you have to try to show the consequent. I did, and that allows me to then pay for line 1. I pay for it with CD, and then I want to box that stuff. Notice what's going to happen when I box the outer box. It's a kind of an annoying feature. The inner box disappears. So always redo or box from the outside in. Just kind of, it's kind of annoying that way. Here you go. And there you go. I'm done. I was able to show that if this, then that. How? I assumed this, and I was able to show that. How did you show that, Mark? Here's how, right? And there you go. That's my thing. And this is a valid argument, and this is the proof of it. By stepwise perfect plumbing moves, right, I was able to do this. How do I shade it? You go like this, ignore, so you go borders and shading. I'm going to go over in shading, and I'm going to take it 10%. And then I'm going to go over here, and I'm going to finish this up. Borders and shading, 10%. And doesn't that look much better? Much easier for you to see. There you go. Done. That's how you would actually do this. My friends, a lot lots happen, and we're going to do, if you want, one more. I'm looking at the time. We're a little over time, but we had a lot on our plate, and I took the time to do some asides. But is this helpful? Type in yes if it is, no if you're lost. Did the homework with you. I did it fast. You're going to take a little longer, obviously. And it's the paper trail, right? How do we back this stuff up? Let's do question 2. All right, first order of business is what? So this is how you find it in the homework. This is what you're going to end up with, but this is how it starts. This is my conclusion. It's already in the box. And this is my premises. First order of business is we want to find out which method. Which method are we going to use for this and why? We're going to use CD because it's a conditional. Good. That's going to require us to do a bit more table setting. So I'm going to move this away, and I'm going to assume P. That's assumption. And it's the kind of assumption that's permitted by conditional derivation. And I'm going to try to show what? I'm going to try to show the consequent. I copy paste, I put this here. Notice I don't need my parentheses, and that is going to be an assertion. And I'm going to put brackets because I haven't paid for it, but it's a reminder that I will have to pay for it. Then you rinse and repeat. You ask yourself, what the hell am I looking at? What am I looking at, taxonomists? I'm looking at a conditional, so I'll have to use a CD. What does that mean? Same damn thing. Assume the antecedent. That's an assumption. It's the assumption of CD. And I'm going to try to show something. What am I going to try to show? I'm going to try to show the consequent. And that is going to be an assertion. I haven't paid for it. I put my brackets and I go over here. I'm going to give myself another row over here. I'm going to move my premises, right? I need a little more space. Got a number of these new rows. What animal am I looking at, people? If it's an elephant, use an elephant gun. If it's anything else, we use ID because it's an atomic proposition. What does it mean to use ID? We'll assume it's falsehood. Fair enough, man. That's what that would look like. And that's going to be an assumption. And that's an assumption that I'm going to make. And that assumption is the assumption ID. All of this is table setting. Then we got to invite the guests because we're going to have a party, right? Here they come. Those are our premises. And now we got to start gossiping. Now we're going to blend things together and we're going to have some fun. Our live lines are what? Lines 2, 4, 6, 7, 8. What can we do? I'm looking at line 2 and I'm looking at line 7 and I'm thinking, you know what? 2 space, I could totally do an MP. If I took lines 2 and I took line 7, I would end up with this as line 9. Stop me, everyone. Is everything perfect plumbing so far? Type in yes if everything's perfect plumbing. No if you've detected that I've done something wrong. I took lines 2, I took line 7, I did an MP, and it got me the consequent of this. Type in yes if I'm doing everything right. No if I made a mistake. You're proofing me. Now you take a deep breath. You look outside your window. At this current state of play, what are my live lines? Tell me number-wise. What are my live lines? The lines that I'm entitled to manipulate. Tell me in the chat. 2, 4, 6, 7, 8, and 9. Agreed. Now give myself another further row. Insert row below. That is going to be row 10. And I'm going to have some more fun. I'm going to say what now? What the hell could I do? Suggestions, people. I got to find a way to pay my bills. I got lots of bills to pay. 2, someone says, 2 and 8 by MP. I could do 2 and 8 by MP. Other suggestions. 4 and 9 by MP. True, true. 4 and 9 by MP. Let's do, which one do you want to do? Ignore or just breathe? So which one? 4, 2 and 8. Give me another one. You could do them all, essentially. 7 and 9 by empty. Can we do 7 and 9 by empty? Yes or no? 7 and 9 by empty. Empty requires the negation of my consequent. Can we do that? Do I have the negation of 7's consequent? No, we can't do that. So we can't do that. Well, we can do, let's say 2 and 8 by MP. Let's do that. 2 and 8. We'll do a bunch of stuff. And there's no harm, this is important, there's no harm in generating lines. 2 and 8 by MP gives me the consequent, and I can trim those parentheses that I don't need anymore. Please do trim them. Perfect plumbers, is everything good? Yes or no? Proof me, perfect plumbers. Cool. What are my live lines? 2, 4, 6, 7, 8, 9, 10. What are some further things we might do? Suggestions. Just generate lots of material for me to work with. So long as it's perfect plumbing, it's fair game. More materials are better than less. 4 and 9 by MP. 4 and 9 by MP. Let's do 4 and 9 by MP. Actually, we can do also, we'll do ignores first, so ignore after. So 4 and 9 by MP gives me what? So I got 4, I've got 9, it gives me R. Perfect plumbers, confirm. Everything perfect? Catch me making a mistake? Sound the buzzer. All right. More suggestions. We had 6 and 10 by MT. We haven't used an MT yet. 6 and 10 by MT. You take 6, that negates this, and what you get is, you get what? Not R. 6 and 10 by MT. Perfect plumbers, can you confirm that everything's perfect? 6 and 10 by MT. Everything is perfect, and we've got ourselves a contradiction. We can start paying some bills. Cross, box, and annotate. How did I pay for line 5? I paid for it using ID. By paying line 5, I thereby pay line 3. How did I pay for that? CD. By paying line 3, I thereby pay for line 1. How did I prove that? CD. I take all of this and I'm going to rebuild my boxes. Over here, I'm going to go borders. I'm going to remove them all. And then I'm going to drag my cursor. And I'm going to put, because we saw a moment ago that it sort of erases the boxes within, I'm going to go from the outside in. Top, bottom, left, right. Here we go. That's the box underneath line 1. Make another box. Top, bottom, left, right. That's the box underneath line 3. And I'm going to go over here. Top, bottom, left, right. And that's the box. Oopsie, I need a little line over here. Here's my top. And that's the box underneath line 1. If you stop there, you've succeeded. If you want to go an extra lap, we can do some shading. Let's do some shading. Why not? Because it looks beautiful. You go over here, borders and shading. You go to shading, 10%. Right? It's like having a marker and you're filling up an area. It's really fun. That's relaxing. You know, it's a victory lap. You've succeeded. And we're going to switch from gray to white to gray to white to gray to white for extra visual clarity. And then you end up with this. And what we have is the paper trail. Someone said this. Well, okay, let's assume that what they said was right. Then this should follow. Well, let's assume that what they said was right, then this should follow. Well, let's assume the contrary of that. Okay, fair enough. And these were the reasons that they had given us. Yeah, fair enough. And then we teased out all of these things. We caught them committing a contradiction, which showed this, which thereby showed this, which thereby showed that. And that would be also 5 out of 5. The extra shading, that's for visual clarity. And certainly in my solutions, I shade them because I want it to be as clear as possible. My friends, this is what the homework looks like. Is everything clear enough to get you started as a starter kit for this week? Yes, you're supposed to highlight the contradictions in red like that, Samuel. Exactly like I did. If I show you, it's because that's how I wanted to make it done. Cool. On a scale of 1 to 10, where's your confidence level? 10 being you're super confident, 1 being like you're terrified and you've just crapped your pants. And you got to be honest. Not bad. Good, 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 good. How do we get more confident, people? What's the trick? You know by now, right? Practice, 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 practice. All right, well, you know you got 3 derivations to do per day. We've already done 2. I want you to redo them, right? That's 21 in all. What do we do for homework now? Read every file on Moodle. All of the stuff that I told you today, I went over once and I went over fairly quickly, but there's a lot in there. Can everyone see under week 9 all of the files? Tell me yes if you can see that. This should be available right now. And notice, good. There's a lot of files in there. I want everyone to reread them carefully. So that's part of your homework. I've put that as the first item. Memorize your first 4 inference rules. There's a file in there that says summary of first batch of inference rules. I want you to commit to memory what an MP and an MT look like. The N and R are kind of a no-brainer, but you need to really be clear on what they are. Also, do 3 derivations a day all week. If you do that, you'll be just fine. If you don't, I'm warning you, you're so screwed. Next week, what are we doing? Well, then we reopen the valves and we add the 6 remaining inference rules, and then we practice some more. The good news is you already know the 3 methods, DD, ID, and CD, right? You've got your inference rules. We're going to add 6 more, and then we're just going to do more of the same until the final exam, and that is it. My friends, is everything crystal clear about what you got to do? If it's crystal clear, type in CC. If you got a question, ask your question. I'm happy to answer. And apologies that I knew we'd have a big class today, and I did some asides, and I showed you some funky images of faces, which was fun. I had a good time showing you that. That's a nice piece. I'm always proud of my work, but it's always cool. I get only a couple people saying everything's crystal clear. Is everyone crystal clear? I just want to touch base with everyone. Remember, I can't read minds. Everyone good? Because if you're lost and terrified, I need to know that as well. If you're not sure what you got to do for homework, you got to let me know. Other than that, it's office time begins and we're saying goodbye. Class is done. We're done. Big workout today. Arguably the toughest of the whole. I mean, I don't know the toughest, but the most crucial. On my end, I had more work, but that is it. Liam, you take care. Good class as well. Isabel, thank you for your great questions. Jackson, you take care. Thank you for spotting some stuff. Edric, same. Dimitro, take care. Cole, see you next week. Practice. Edison, same. Have a good day, Jaspreet, as well. Ignore, you have a good week. Good class, agreed. We did a good class, 2 hours and a half. I'm spent, but I'm sticking around for what it's worth. I'm the last one to leave the room. Spencer, you have a good day as well. Hannah, amazing work again. Great questions. I'm happy that it takes me a little while sometimes to wrap my mind around what folks are saying. Yeah, Samuel, and isn't it the thing is though, right? I'm Bardia. You take care. Same, Raman. I feel like I don't deserve a ton of credit because I feel like the system I'm teaching you is gorgeous. Like the fact that I can even paraphrase this into ordinary conversation settings, that's a testament to how beautiful the mechanism is, right? I mean, that it reflects our ordinary back and forth of reason-giving practices is quite a thing because we do make assumptions and for the sake of argument, and then let me prove you this other subsidiary point, and then we do a detour, and then we round back, and it's quite a thing. I'm humbled by the method I'm teaching you. Well, I agree, Samuel. If you ever want to see the textbook that I've used to kind of build this course out of, it is absolutely terrifying, and my class is like as super accessible. But the system I'm grabbing, I find it gorgeous because there's different proprietary blends of inferences. The 10 inference rules that I'm teaching you are from a particular system, Kalish, Marr, and Montague, if you ever want to look that up. Techniques of Formal Reasoning, Kalish, Marr, and Montague. That's the second edition. Look up that book and you'll find how frightening it is. But the system is beautiful. So what I've done is I've extracted what I thought was a gorgeous system and then I've tried to make it as accessible as possible. Yeah, I agree, Samuel. It doesn't get much better than this. Trust me, I agree. And you only know that when you've shopped around. Folks sometimes take it for granted if all they've done is come in my class. Like I've heard, like if you don't have a sense of Techniques of Formal Reasoning, second edition, Kalish, Marr, and Montague. That's the system I'm using, is ripped off of them with a few notational modifications. Because I've worked, I did my postdoc in philosophy of notation. I'm aware of certain things I want to fine tune, but yeah, that's from theirs. Yeah, very frightening book. Very frightening book that goes way beyond what we want to teach in a class like this. Yeah, but if anyone's ever curious, cool. Yeah, it can be rough, right? And the thing is, even in the best case scenario, kids are a bit terrified, and rightly so. It's a lot to take in and requires practice. So, but yeah, certainly I'm handling a difficult file. It's quite the thing. It's quite the thing. And it's hard because you got smart kids like you, right? You got good students who are keen on engaging and show up. But there's also a lot of people who are, I would call, the silent terrifieds, and I don't hear from them, and they're there, and I'm aware. And so, yeah. And so one of the things I have to be mindful all the time, this is very important. It's like if I was in a classroom, you don't just speak to the kids in the front row, right? You have to address people, all the people, including the people in the back row who are terrified because this is not for whatever reason, it's not picking up so rapidly. And that's not that a start doesn't mean an end. So it's not because you don't pick up something rapidly at the beginning that says how are you going to end. If there's anything that the tortoise and the hare teaches us is that it ain't over till it's done, right? But and so I try to address everyone and as much as possible. That's why it's crucial that people be honest. If they are lost, I can't throw them a buoy unless they scream. Like I can't throw them a safety, what are it called when you're at sea and you cast those life jackets, the thing that floats, right? Yeah. And it feels like a puzzle, a lifeline, exactly. It feels like a puzzle. And the thing that's going to be fun is that it's going to be fun. As you get the hang of this, the challenge, especially, and it's nice that I'm recording this still because this is going to be on record for folks to verify it later. When you're going to be stuck in derivations, sometimes the only way to get unstuck, and I'm warning you for your homework this week because it's bound to happen. The only way to get unstuck, if you're just genuinely stuck, it's not just mechanically producing further and further lines, is to call a strategic show line, a show line which, were it to be shown, would really get things into gear. So you say show, and then you type in, it's your blank check, right? What you would like to have, right? But doesn't mean you have it. But man, if I had it, things would move forward. And then you call that show line. The content of what you're going to write next to that show line, that uncrossed show line, that's what's going to make this method different than sort of the stuff that we learned out with truth tables, which were purely mechanical. That's a non-mechanical moment. That's really human. It's a human moment, right? Where we generate a fresh hypothesis. Kind of like if you went to my AI talk when I was talking about abductive reasoning. Yeah, this is the moment where you're going to do abductive reasoning. We're going to say, were this to be true, holy cow, would these things follow? And then you have to sort of make good on that promissory note. Yeah. Yeah. Well, Edric, if you look online, you're going to find a lot of stuff and probably more scary than mine. So if you stick to my stuff, if you ever get terrified, you don't need to do anything beyond my class, but there's lots out there. This is standard material. Yeah. You take care, Samuel. See you next week. And Sakshi, Avneet, Samuel, Michael, anybody else who needs me, you let me know in the chat. Hannah, same. If you're still around, I'm absolutely there for you. Yeah, you take care, Edric. Good work. Yeah, Anna, and a great question, Anna. And again, you'll see this. Your point was, I think, a good one. I just didn't see that as first. But there's that element of freedom I just spoke about a moment ago. You're going to find it really fun because, and by the way, if you F up, if you called for a show line you can't make good on, you can't actually pay your bills, just go back. Like use your undo button. It's no big deal. But it'll be fun for you to kind of work through what would happen if, right? Yeah. And there were no assumptions in the short truth table method. So that's the thing that is different. There's an element of freedom in the order in which we were selecting our entry points. That's the element of freedom. But the freedom here is far more radical. It's the freedom to write your own ticket. And for what it's worth, I'm interested in questions of AI, sort of algorithmically capturing what it means to reason. That's the part that is distinctively human. If you want to sort of say, what's the creative moment in our inferential processes that's not reducible to a rule, the moment when we generate what are the potentially fruitful hypotheses is that moment. And it's not obvious to program an AI with that. The AI can try to map us, but that's just because we already know that we do it well. It's not even clear why we do it well and how. And so there are interesting philosophical questions. If you do a philosophy of logic course where we just basically think about what the hell we're doing right now and just pause with that one system and sort of microanalyze those moments and go under the hood and see, what are the philosophical presuppositions. It's very interesting to look under that particular hood. And I'm interested. I actually don't publish in logic, but I do publish in philosophy of logic. So I find those questions immensely interesting. Yeah. Because there's just the mechanics of doing these things, but then there's like stopping and reflecting on what it is exactly we're doing, which is just, to my mind, equally or more interesting. Yeah. On that note, if anyone needs me for anything, including philosophy for what it's worth, I'm there. Other than that, then it's goodbye and see you next week. 3 a week, 3 a day. 3 a day keeps the bad stuff away. We're going to learn more inference rules. So there's going to be 10 in all, Edric. So the summary sheet that I had you look at just for briefly, we're going to have 10 in all. So 4 this week and then 6 more next week. So six more inference rules. Yeah. So we're going to have 10. and then you're going to have to know those by heart and deploy them. Um, I don't know, and I was invited. I doubt they would double dip for the no problem. I doubt that they would invite me again because they've already done so. But I accept invitations if and when they're good ones, and so in general, I'm available. Yeah. So Langara College. So Edric asked with Philosopher's Jam. Langara College has a little a monthly, I would imagine, speaker series or bi-monthly, whatever it is. And they invited me in January, was it January or February, to give a talk about some of the stuff I'm thinking about right now, which is AI and chatbots and whatnot, the work that I do in philosophy of technology. And I did, and it was fun. But the good news is, Hannah, if you're ever interested in that kind of stuff, a lot of that shows up both in my monthly newsletter and in my forthcoming book. So I do write out that stuff. The jam is a space to sort of work out orally some of these ideas, but then all of that ends up being in print eventually. So there's a workshop there, and I'm working through these ideas, and I'm writing a book called Endangered Experiences. It's a book on technology. Yeah. Yeah. Well, I mean, you just Google me up, Edric. So just Google my name, and you'll find everything. Yeah. Yeah, lots of things. Yeah, so I'm just curious. I'm always writing about all sorts of stuff, and there's a moment when it's kind of oral, and there's a moment when it's kind of written, and obviously the written stuff's more robust. But there's a phase when it's written, and then I sometimes give talks. I give less and less talks because they're a bit of a pain in the butt. So I don't come out of my cave very often. So it has to be a very nice invitation. But yeah, I don't give a lot of talks. They're just not worth my while anymore. So I just basically write. Yeah. But there's an abundance of material there. So have a look if you're interested. I'm happy to share. It's all out there, mostly for free. I violate all my copyrights and put them all for free as far as I can. Yeah. Don't tell my publisher, but yeah. Yeah, cool. And including some philosophy of logic stuff. Yeah. So I do have a recent piece in a journal called History and Philosophy of Logic, where I discuss mostly, I talk about a system of logic that I haven't introduced you folks to, but most of the piece could be understandable even if you haven't learned it. So you might make some sense out of that. It's called A Semiotic Pragmatic Defense of Bivalence, in 2022 issue of History and Philosophy of Logic. So I do occasionally dabble in that area. Got lots of interests, but that's one of my interests. That if I have time and energy permits, I like working on that. Yep. Cool. I have to say, by the way, Edric and Anna, and it's great to have good students like yourselves. So I just want to give a bump knuckle to both of you. Well, and you've been really good students. It's a joy to have you be so keen and interested and putting your work out there in the chat and taking risks. And no one wants to sort of make a mistake, but they're part of what we do. And whenever you write, you make a mistake. It's okay. Yeah. Yeah. Thank you. Well, good. Bump knuckles for that. Yeah. Did I say headbutt or bump knuckles? My kids, as you can tell, are going crazy. But yeah, that's what it is. All right, my friends, on that note, I'm very happy the class went well. This is the end. We did it. Take care. I'll talk to you next week. I'm out of the fryer and into the frying pan. As soon as I'm done, I'm going to go tend to some disasters in my private life. Good. Take care. Michael and Saksi, more like a furnace. Yeah. Anything else I can do for you? If not, I'm going to wrap it up. So going once, going twice. Good. All right, everyone. Well done for today's class. It was a little longer, but I expected as much. We are trying to cram as much as possible, but I want to give you everything you need to do your homework. And you should, but I can't do the homework for you. Take care, everyone.